From Waterfall to Agile and beyond, navigating software development methodologies. Chapter 1, The Blueprint for Success, Why Methodologies Matter. 1.1, The Challenge of Building Software. From idea to reality. Imagine you have a brilliant idea for a new piece of software. Perhaps it's a groundbreaking mobile app that connects communities, a powerful tool to streamline a business process, or a complex system to manage global logistics. The idea in your mind is crystal clear, perfectly defined. You picture the sleek interface, the seamless user experience, and the incredible impact it will have. Now, how do you transform that powerful vision into tangible, working software? This transformation is far more complex than it might first appear. It's not simply a matter of a few people sitting down and typing code. Building software, especially anything beyond the simplest utility, involves a multifaceted dance of people, processes, and technology. It requires understanding the true need. What problem are we really trying to solve, and for whom? This often means deciphering vague requests and turning them into precise, measurable requirements. Designing the architecture. How will all the different pieces of the software fit together? What foundational technologies will it rest upon? Writing the code. Translating designs into instructions that computers can understand, line by painstaking line. Testing for quality. Ensuring the software works as intended, is free of errors, and delivers on its promise. Managing change. Ideas evolve, user needs shift, and unexpected challenges arise. How do you incorporate these changes without derailing the entire effort? Meeting deadlines and budgets. Delivering the software on time and within financial constraints is a constant balancing act. Coordinating teams. Developers, designers, testers, product managers, and customers all need to collaborate effectively. Without a clear roadmap, this journey from idea to reality can quickly become a chaotic, frustrating, and expensive ordeal. Projects can spiral out of control, miss their mark entirely, or even fail before ever seeing the light of day. This is where software development methodologies come in. 1.2, What is a software development methodology? At its heart, a software development methodology is a framework that structures, plans, and controls the process of creating software. Think of it as a set of agreed-upon principles, practices, and guidelines that dictate how a software project will be approached, from conception to delivery and beyond. To use an analogy, consider building a house. You wouldn't simply start pouring concrete and nailing planks together without a plan. You'd need a blueprint. This defines the overall structure, room layouts, and engineering specifications. A construction plan. This outlines the sequence of work: foundation first, then framing, then roofing, and so on. Roles and responsibilities. Who is the architect, the general contractor, the plumber, the electrician? Communication protocols. How do the different trades coordinate their work? Quality checks. When do inspections happen? A software development methodology serves a similar purpose. It provides the blueprint for your software, the construction plan for how it will be built, the definition of roles for your team members, and the protocols for interaction and quality. Just as there are different styles of architecture, traditional, modern, minimalist, and different construction management philosophies, design build, general contracting, there are various software development methodologies, each with its own philosophy and preferred practices. These methodologies provide a structured way to answer critical questions. What is the process for gathering requirements? How will we manage changes? When and how often will we deliver working software? What roles are needed on the team, and what are their responsibilities? How do we ensure quality throughout the project? How do we communicate with stakeholders and customers? In essence, a methodology transforms a potentially messy and unpredictable endeavor into a defined, repeatable, and manageable process. 1.3, Why methodologies are essential. Bringing order to complexity. The primary reason software development methodologies are essential can be distilled into one core goal: bringing order to complexity. Software projects, by their very nature, are complex undertakings. They deal with abstract concepts, constantly evolving technology, and the inherent variability of human understanding and customer needs. Without a shared methodology, chaos can quickly ensue. Here are some key benefits that methodologies provide, making them indispensable for successful software creation. Enhanced efficiency. By providing a structured workflow, methodologies help teams streamline their activities, reduce redundant efforts, and focus on value-adding tasks. Everyone knows what they need to do, when they need to do it, and how their work connects to the overall goal. Improved quality. Methodologies often embed quality checks, testing phases, and feedback loops throughout the development process. This allows teams to identify and address issues early, significantly reducing the cost and effort of fixing bugs late in the project. Greater predictability. While no software project is entirely predictable, a well-chosen methodology allows for more accurate estimations of timelines, costs, and resources. This helps stakeholders plan effectively and manage expectations. Effective risk mitigation. By breaking down large projects into smaller, manageable chunks, and by fostering continuous feedback, methodologies enable teams to identify and address potential risks, technical, market, operational, much earlier. This reduces the chances of catastrophic failure. Clear communication and collaboration. Methodologies define common processes, terminology, and artifacts, like documents or communication channels. This fosters better understanding and collaboration within the development team and with external stakeholders, ensuring everyone is on the same page. Defined roles and responsibilities. A methodology clearly delineates who is responsible for what, minimizing confusion, overlap, or critical gaps in accountability. This empowers team members and ensures that all necessary tasks are covered. Adaptability and responsiveness. Some methodologies, particularly more modern ones, are specifically designed to embrace change rather than resist it. This allows teams to respond quickly to new requirements or market shifts, ensuring the delivered software remains relevant and valuable. In short, a methodology acts as a shared framework that aligns people, processes, and technology, increasing the likelihood of delivering high-quality software that meets its intended purpose, on time and within budget. 1.4 A brief history of software development, the software crisis, and the search for structure. To truly appreciate the value of methodologies, it's helpful to understand the context in which they emerged. The story of software development methodologies is, in many ways, a response to a recurring problem, the software crisis. This term first gained widespread recognition in the late 1960s and early 1970s. As computers became more powerful and complex software systems became feasible, the industry faced a significant challenge. Projects were routinely over budget, costs far exceeded initial estimates, behind schedule. Delivery dates were frequently missed. Bug-ridden, the software often contained numerous errors, leading to instability or incorrect functionality, failed to meet user needs. Despite significant investment, the final product often didn't solve the intended problem or was difficult to use. Difficult to maintain. As systems grew, modifying or updating them became a nightmare. This crisis was a direct result of software engineering being a nascent discipline. Many early programmers approached projects with an unstructured, ad hoc approach. They might start coding with a vague idea, fixing issues as they arose, often leading to what became known as spaghetti code, a tangled mess of logic that was nearly impossible to understand or change. The software crisis highlighted a fundamental need. The industry recognized that simply having talented programmers wasn't enough. A systematic, disciplined approach was required. This realization spurred the birth of software engineering as a formal field, and with it, the earnest search for repeatable, predictable, and effective ways to build software. The very first methodologies, heavily influenced by traditional engineering and manufacturing disciplines, began to take shape as attempts to impose order on this chaotic landscape. 1.5 What's ahead? A glimpse into the evolution of methodologies. From those early, often rigid, attempts to control development, a diverse and evolving landscape of methodologies has emerged. The journey has been one of continuous learning and adaptation, driven by changing technology, market demands, and a deeper understanding of how creative teams best function. In the chapters that follow, we will embark on a fascinating journey through this evolution. We will start with the foundational, sequential approaches like the Waterfall model, understand their strengths and weaknesses, and see why they often struggled under the demands of modern software. We will then explore how iterative and incremental approaches began to introduce much-needed flexibility, paving the way for the Agile revolution. A significant portion of this book will be dedicated to the pervasive Agile frameworks, including Scrum and Kanban, dissecting their principles, practices, and how they empower teams to deliver value rapidly and adaptively. We will also delve into lean software development, which focuses on eliminating waste and maximizing value, and DevOps, a cultural and technical movement bridging development and operations to accelerate delivery and improve reliability. Beyond these major players, we'll briefly touch upon other specialized methodologies and consider how various approaches can be combined to create hybrid solutions. Crucially, we will dedicate an entire chapter to guiding you through the process of choosing the right methodology for your specific project, team, and organizational context. The ultimate goal of this book is not to declare one methodology superior to all others. Instead, it is to equip you with the knowledge and understanding to navigate this complex terrain, appreciate the unique strengths and applicability of each approach, and ultimately, help you and your teams make informed decisions that lead to successful software development. Whether you're an aspiring developer, a project manager, a business leader, or simply curious about how technology is brought to life, understanding these blueprints for success is an invaluable asset. Chapter 2: The Old Guard. Understanding Waterfall Development. 2.1 Genesis and Core Principles. The Sequential Approach. In the nascent days of computing, as software became more complex and pivotal, organizations sought ways to manage its development with the same rigor and predictability as other engineering disciplines. The most prominent model to emerge from this pursuit was the waterfall model. Its genesis can be traced back to manufacturing and construction industries, where a highly structured, sequential approach was the norm. While the term waterfall wasn't widely used until later, and its definitive paper by Winston Royce in 1970 actually critically analyzed the purely sequential approach, advocating for more iteration. The simplified, linear depiction became the prevailing interpretation. The core principle of the waterfall model is its sequential and linear flow. Much like a physical waterfall, each stage of development flows downwards, into the next, with no apparent way to go back upstream. This model assumes that all requirements can be fully known, understood, and documented upfront before any design or coding begins. Each phase must be completed and signed off before the next phase can commence, creating distinct gates in the project timeline. This highly structured approach was initially seen as a way to impose order and discipline on what was often a chaotic development process. It promised predictability, clear milestones, and comprehensive documentation at each stage, mirroring the successful methodologies from fields where requirements were fixed and changes were costly and rare. 2.2 Deconstructing the phases. Requirements, design, implementation, verification, maintenance. The waterfall model is characterized by its distinct, non-overlapping phases. Let's break down each one. Requirements gathering and analysis. This is the foundational phase and arguably the most critical in Waterfall. The goal is to comprehensively understand and document all the customer's needs and system functionalities. This involves extensive client interviews, workshops, and drafting detailed specifications. The output is typically a software requirement specification (SRS) document, which serves as the definitive source for the entire project. Once this document is finalized and approved, it is generally considered immutable for the remainder of the project. Imagine laying the entire blueprint for your house, down to every electrical outlet and paint color, before you even dig the foundation. System design. Based purely on the approved requirements document, the design phase translates those requirements into a detailed software architecture. This involves designing the system's overall structure, defining software and hardware requirements, sketching database designs, outlining user interfaces, and determining communication protocols. The output is a design specification document that acts as the blueprint for the coding team. This phase dictates how the system will be built to meet the what defined in the requirements. Implementation, coding. With the design firmly in hand, developers begin writing the actual code. Each module or component defined in the design phase is developed and unit tested in isolation to ensure it meets its specific technical specifications. This phase typically sees little direct interaction with the customer, as all decisions are presumed to have been made in previous stages. Verification, testing. Once all components are implemented and integrated, the software enters the testing phase. This is comprehensive and often includes various levels of testing. Integration testing, verifying that different modules or components work together correctly. System testing, testing the complete integrated system to ensure it meets the overall requirements. User acceptance testing, UAT. The customer or end users perform tests to confirm that the system meets their business needs and is ready for deployment. Any defects found are logged, fixed, and retested. This phase is about validating the entire system against the original requirements. Maintenance. This is the post-delivery phase, encompassing all activities once the software has been deployed to users. It includes bug fixes found in production, implementing minor enhancements requested by users, often treated as new, smaller waterfall projects, and adapting the software to changes in the operating environment, e.g., new operating systems. The strict adherence to this sequence means that any changes to requirements discovered during, say, the testing phase are incredibly difficult and costly to implement, as they would theoretically necessitate going back to the very first phase. 2.3 The V model, an extension of Waterfall for quality focus. While not fundamentally different from Waterfall, the V model can be seen as an extension or refinement that places a stronger emphasis on testing and quality assurance throughout the development lifecycle. It emerged in response to the common problem in Waterfall, where errors discovered late in the testing phase were very expensive to fix. The V model illustrates the relationship between each development phase and its corresponding testing phase. The left side of the V represents the development phases, requirements, design, implementation, moving downwards. The right side of the V represents the testing and verification phases, unit testing, integration testing, system testing, user acceptance testing, moving upwards, connecting each testing phase directly to its corresponding development phase. For example, requirements are validated during user acceptance testing. System design is validated during system testing. High-level design is validated during integration testing. Low-level design is validated during unit testing. The core principle remains sequential, but the V model highlights that for every development step, there is a corresponding test activity. This encourages thinking about testing earlier in the process, though the actual testing execution still happens later. It's still largely a linear process, but with an explicit focus on verification and validation activities aligned with creation activities. 2.4 Strengths of Waterfall, where simplicity and structure shine. Despite its reputation for rigidity, the waterfall model does possess certain strengths that make it suitable for specific types of projects. Simplicity and ease of understanding. Its linear structure makes it intuitively easy to understand and apply, especially for teams new to structured development or for projects with very clear, unchanging goals. Clear milestones and deliverables. Each phase has a distinct completion point with defined deliverables, e.g., the SRS design document. This provides clear checkpoints for project managers and stakeholders to track progress. Strong documentation. The emphasis on documentation at each stage means that projects have comprehensive records. This can be beneficial for long-term maintenance, onboarding new team members, or for external audits. Predictability for stable projects. If requirements are absolutely stable, well understood, and unlikely to change, Waterfall can offer a relatively predictable timeline and budget, as the entire project is planned upfront. Suitability for regulatory compliance. In highly regulated industries, e.g., medical devices, aerospace, defense, where rigorous documentation, traceability, and strict adherence to specifications are mandatory, the waterfall model's comprehensive and auditable paper trail can be a significant advantage. For projects where the problem domain is exceptionally well defined, the technology stack is stable, and there is minimal likelihood of changes in requirements, waterfall can theoretically work. Consider a known solution being ported to a new platform with a very specific, unchanging set of features. Here, the rigidity might be less of a hindrance. 2.5 Critical limitations and common pitfalls. Why Waterfall fails for modern projects. While Waterfall offers apparent simplicity, its limitations often outweigh its benefits, particularly in the context of modern software development. The sequential nature, which was its initial strength, becomes its Achilles heel in a rapidly changing world. Here are the critical drawbacks that led to its decline for many projects: inflexibility and resistance to change. This is the most significant limitation. Waterfall assumes that requirements can be fully captured and locked down at the very beginning. However, in reality, requirements often evolve due to changing market conditions, business needs, or user feedback. Introducing changes late in the cycle is extremely difficult, costly, and can jeopardize the entire project timeline and budget. Imagine redesigning a significant portion of your house after the roof is already on, simply because you realized you needed 2 more bathrooms than initially planned. Late detection of defects and errors. Since testing is primarily deferred until the later stages, critical design flaws or fundamental misunderstandings of requirements may not be discovered until late in the project. The cost of fixing a bug or correcting a design error found during the testing phase is exponentially higher than if it were caught in the requirements or early design stages. Limited customer involvement. Beyond the initial requirements gathering, customer involvement is minimal until the final user acceptance testing. This means there's less opportunity for ongoing feedback, leading to a higher risk that the final product might not actually meet the evolving needs or expectations of the users. The Big Bang delivery can often lead to disappointment. High risk for complex or long-term projects. For large, innovative, or long-duration projects, the initial requirements can become stale or obsolete before the project even reaches completion. The upfront investment in extensive documentation and planning can be wasted if the target shifts mid-course. Big Bang, integration, and delivery. Everything comes together at the very end. If there are unforeseen integration issues between components, or if the system doesn't perform as expected when finally put together, finding and fixing these issues can be a massive and stressful undertaking, often leading to significant delays and budget overruns. Demotivating for teams. The long cycles without seeing working software, the rigid adherence to plans, and the blame associated with late-stage discoveries can lead to a demotivated development team. Ultimately, the waterfall model struggles with the inherent uncertainties and dynamic nature of most software projects. It is built on the false premise that software requirements are static and perfectly discoverable upfront, which rarely holds true. 2.6 Case study, when waterfall made sense and when it didn't. While the waterfall model has largely been superseded by more adaptive approaches for most modern software endeavors, understanding its historical context reveals where it was once the logical choice, and where its inflexibility became its undoing. A case where waterfall historically made sense: space shuttle flight software, early days. Consider the development of flight control software for the NASA Space Shuttle program in its early phases, dating back to the 1970s and 80s. This was a domain characterized by exceedingly stable requirements. The physics of spaceflight, the design of the shuttle, and the mission parameters were meticulously defined and changed very little. Any modification could have catastrophic consequences. Extreme criticality, lives were at stake, and failure was not an option. This demanded rigorous documentation, formal verification, and an auditable trail for every decision. Known technology. While complex, the underlying computational and control systems were largely well understood at the time of design. Long planning cycles. These massive government programs inherently had multi-year planning and execution cycles. In such environments, the emphasis on upfront analysis, meticulous design, comprehensive documentation, and sequential testing provided the necessary discipline and accountability. Changes were deeply frowned upon and subjected to immense scrutiny, making the waterfall's inflexibility a feature, not a bug. A case where waterfall famously failed, and why it represents a broader trend. Large government IT systems, 1980s, 1990s. Many large-scale government IT projects in the 1980s and 90s, particularly in defense or public services, were mandated to follow strict waterfall methodologies. The assumption was that due to their size and public funding, they required maximum control, planning, and documentation. However, these complex, multi-year projects frequently encountered significant problems, changing user needs. Over a 3 to 5 year development cycle, the very laws, regulations, or public needs that the system was meant to serve would often change. By the time the software was delivered, it was already obsolete or no longer fit for purpose. Technological obsolescence. The hardware or software platforms chosen at the beginning of a multi-year project would quickly lose relevance, or better, cheaper alternatives would emerge. Budget and schedule overruns. The rigid structure meant that late-stage discoveries of major issues, e.g., a fundamental flaw in the initial requirements, could only be addressed by going back to the start, leading to massive cost increases and years of delays. Low user adoption. Because users had little input after initial requirements, and the system took so long to develop, they often found the final product cumbersome, difficult to use, or simply not what they truly needed anymore. One widely cited example, while not a single named project, is the general trend of large U.S. government IT project failures documented by the Government Accountability Office, GAO, during that era. These reports frequently highlighted how rigid, long-cycle methodologies struggled to adapt to evolving technology and policy, leading to expensive failures. These widespread failures became a powerful catalyst for the industry to seek more adaptive, responsive, and iterative ways of building software, setting the stage for the methodologies we will explore in the coming chapters. The lessons learned from Waterfall's limitations fueled the demand for approaches that could embrace change rather than resist it. Chapter 3. Stepping towards flexibility, iterative and incremental approaches. 3.1. The need for agility, recognizing Waterfall's shortcomings. As the software crisis deepened through the 1970s and 80s, the industry's collective frustration with the rigid confines of the Waterfall model grew. It became overwhelmingly clear that software development was fundamentally different from constructing a bridge or a building. Unlike physical structures, software is inherently abstract. Its requirements often emerge and evolve over time, and the underlying technology changes at a dizzying pace. Imagine ordering a custom-built car. With a traditional waterfall approach, you'd specify every detail up front: engine size, color, interior materials, infotainment system. Then the manufacturer would disappear for 2 years, only to return with the finished vehicle. What if, during those 2 years, self-driving technology emerged or your family grew, requiring more seats? You'd be stuck with a perfectly executed, but potentially obsolete or unsuitable vehicle. This was precisely the challenge faced by software teams. Projects often stretched on for years, by which time the market had shifted, competitors had delivered similar solutions, or the initial user needs had changed dramatically. The Big Bang delivery, where users saw the finished product only at the very end, often resulted in disappointment because it no longer matched their needs or expectations. The inherent resistance to change within Waterfall wasn't just costly, it stifled innovation and delivered irrelevant products. There was a critical need for approaches that could embrace change, acknowledge that requirements would evolve and allow for flexibility, provide early feedback, get working software into users' hands sooner to gather their insights, reduce risk, break down large, uncertain projects into smaller, more manageable parts, deliver value continuously, provide tangible benefits throughout the project, not just at the very end. This recognition spurred the development of alternative models that, while not yet agile in the modern sense, took significant steps towards greater flexibility and adaptation. 3.2. Understanding iterative development. Cycles of refinement and feedback. One of the first significant departures from pure waterfall was the concept of iterative development. Instead of completing each phase once for the entire project, iterative development involves repeatedly cycling through development phases: planning, analysis, design, implementation, testing. in discrete, self-contained mini-projects called iterations or cycles. Think of it like sculpturing. With Waterfall, you try to plan the entire statue from the start, then chisel every detail perfectly without ever stepping back to see the whole or getting feedback partway through. With iterative development, you start with a rough sketch, then sculpt a general form in one iteration, refining it in the next, then adding more detail in subsequent iterations, constantly stepping back to assess the work and make adjustments. Key characteristics of iterative development: repetitive cycles. The project is broken down into multiple, fixed-length iterations. Each iteration produces a working, albeit incomplete, version of the software. Feedback loops. At the end of each iteration, the working software is reviewed, typically by stakeholders and users. This feedback is then incorporated into the planning for the next iteration. Refinement and evolution. Requirements and designs can evolve over time as new information is gathered and learning occurs. The software grows and improves with each cycle. Risk reduction. By tackling smaller chunks and getting early feedback, risks are identified and addressed sooner, preventing them from snowballing into catastrophic problems. The focus of iterative development is on refinement and learning. Each iteration delivers a working version of the software, even if it's just a subset of the eventual full product. This allowed teams to learn from actual usage, respond to unforeseen challenges, and gradually build a more robust and relevant solution. 3.3. Understanding incremental development. Building and delivering piece by piece. Closely related to iterative development, and often used in conjunction with it, is incremental development. While iterative development focuses on refining a single product through successive cycles, incremental development focuses on delivering the product in discrete, functional chunks or increments. Each increment adds new functionality to the software, delivering value progressively. Using our car analogy, if iterative development is about refining the design, start with general shape, then refine contours, then add specific features. Incremental development is about delivering functional parts of the car. In one increment, you might deliver a working chassis. In the next, a chassis with an engine. Then, a chassis with an engine and a basic interior. Each increment is a complete functioning component, even if the full car is still years away. Key characteristics of incremental development. Phased rollout. The software is built and delivered in stages, with each stage adding a new, cohesive set of features. Early value delivery. Users get working software, albeit with limited functionality, much sooner than with Waterfall. This allows them to start using the software and realizing benefits earlier. Manageable scope. Each increment has a defined scope, making it easier to plan, develop, and test. Subset of functionality. Each increment delivers a usable subset of the overall product's functionality, which can be deployed and used independently. When iterative and incremental approaches are combined, it forms a powerful strategy. Each iteration provides a working software increment, which is then refined and expanded in subsequent iterations based on feedback. This powerful combination allows for continuous delivery of value while adapting to new information and changes. 3.4. The spiral model. Risk-driven and iterative. One of the most prominent early models to explicitly combine iterative and incremental approaches with a strong focus on risk management was the spiral model, proposed by Barry Boehm in 1986. The spiral model is depicted as a spiral with multiple loops. Each loop, or cycle, represents a phase in the project's development. Unlike Waterfall, which is linear, or simple iterative models that repeat phases, the spiral model cyclically goes through 4 main activities for each loop. Objective setting. Determine the objectives, constraints, and alternatives for this portion of the project. Risk assessment and reduction. This is the heart of the spiral model. Identify potential risks, technical, market, operational. Analyze them and develop strategies to mitigate them through prototyping, simulation, or other risk reduction activities. This phase is crucial for deciding whether to proceed, terminate, or adjust the project. Development and validation. Develop and test the necessary functionalities for the current increment. This could involve waterfall-like methods, iterative development, or prototyping. Planning the next phase. Evaluate the results of the current cycle, including risk assessment, and plan the next iteration of the spiral. The radius of the spiral represents cumulative cost, and the angular dimension represents progress through the cycles. Projects move through the spiral, adding functionality and reducing risk with each rotation. The spiral model explicitly acknowledges that software development is risky and that managing those risks should be central to the process. It's particularly well-suited for large, complex, and high-risk projects where requirements are uncertain. 3.5 Rational Unified Process, RUP, a structured, iterative framework. Another significant iterative and incremental framework that gained widespread adoption, particularly in larger enterprises, was the Rational Unified Process, RUP. Developed by Rational Software, later acquired by IBM in the late 1990s, RUP is a highly structured, repeatable, and visual approach to software development, often described as an industrial-strength framework for object-oriented software engineering. RUP is not a single, rigid sequence of steps. Instead, it's a configurable framework that focuses on 4 primary phases, cycled through iteratively. Inception: define the project scope, business case, and vision. Identify key requirements and risks. The goal is to establish project feasibility and gain stakeholder agreement. Elaboration: design the architecture, analyze key requirements in detail, and mitigate major risks. The output is a robust baseline architecture and a refined understanding of the solution. Construction: this is where the bulk of the development occurs. Components are built, integrated, and thoroughly tested, driven by a series of iterative cycles. Transition: deliver the system to the end users, including beta testing, deployment, and user training. Throughout these phases, RUP emphasizes disciplines such as business modeling, requirements, analysis and design, implementation, testing, deployment, configuration and change management, and project management. What makes RUP unique is its focus on use cases for defining functionality, and its heavy reliance on Unified Modeling Language, UML, for visual design and documentation. RUP's strengths lay in its comprehensiveness, its ability to scale to large projects, and its strong emphasis on architecture, quality, and rigorous documentation. However, due to its detailed nature and extensive artifacts, it could be perceived as heavyweight or bureaucratic, particularly for smaller, rapidly evolving projects. It could be tailored to be lighter, but the default often involved significant upfront planning and documentation, a trait it shared, albeit to a lesser extent, with Waterfall. 3.6 The Legacy, paving the way for the Agile revolution. The models discussed in this chapter, iterative, incremental, spiral, and RUP, represent crucial stepping stones in the evolution of software development. They fundamentally challenge the waterfall dogma of doing everything once and perfectly upfront. By introducing cycles of feedback, risk mitigation, and phase delivery, they demonstrated that change is inevitable and manageable. It doesn't have to break the project. Early feedback is invaluable. It leads to better products. Delivering small, working pieces is better than a single big bang. It allows for course correction and early value realization. While these models provided significant improvements over Waterfall, they still often retained elements of formality, extensive documentation, and upfront planning that could slow down development in rapidly changing environments. They were certainly more flexible, but perhaps not yet agile enough for the impending internet boom and the need for even faster time to market. The lessons learned, the successes, and even the remaining frustrations with these more flexible, yet sometimes still heavy approaches, ultimately catalyzed a further revolution. The desire for even greater speed, responsiveness, and a focus on core values over rigid processes would lead to the widespread adoption of what we now call Agile methodologies, which we will explore in the next exciting chapter. These early iterative and incremental models were not just alternatives, they were the fertile ground from which the Agile movement would spring. Chapter 4: The Agile Revolution. Principles and Values. 4.1 The Genesis of Agile. The Snowbird Meeting and the Manifest. By the turn of the new millennium, the internet had fundamentally reshaped industries and customer expectations. The pace of change accelerated dramatically, and the software development methods of the past, Even the iterative ones often felt too slow, too rigid, and too disconnected from rapidly evolving market demands. Many projects, despite best efforts, still suffered from long development cycles, delivered software that no longer matched user needs, and struggled to react to competitive pressures. Against this backdrop of frustration, a pivotal moment occurred in February 2001. 17 independent-minded software developers and thought leaders, tired of the bureaucratic and documentation-heavy approaches prevalent at the time, gathered at a ski resort in Snowbird, Utah. These individuals represented various emerging lightweight development approaches like extreme programming, XP, Scrum, DSDM, adaptive software development, Crystal, feature-driven development, and pragmatic programming. They shared a common belief: there had to be a better way to build software. Their goal was not to establish a new methodology, but to discover common ground, the shared values and principles that made their diverse approaches more effective than the traditional waterfall-based methods. After 2 days of intense discussion, collaboration, and debate, they published a concise statement of their shared philosophies. The Manifesto for Agile Software Development, famously known as the Agile Manifesto. This short document, along with a list of 12 supporting principles, didn't prescribe how to do software development. Instead, it articulated a set of foundational values and principles that would guide developers and organizations towards more effective, adaptive, and human-centric ways of working. It was less about process and more about mindset. The name Agile itself was chosen to reflect their core desire for speed, adaptability, and responsiveness to change. 4.2. The 4 core values of the Agile Manifesto. The Agile Manifesto is built upon 4 fundamental values, each presented as a preference for one side of a dichotomy while acknowledging the importance of the other. The key is the emphasis on valuing the items on the left more than the items on the right. 1. Individuals and interactions over processes and tools. What it means: this places a premium on the human element. While processes and tools are necessary, they should serve the people, not the other way around. Effective communication, collaboration, and mutual respect among team members are far more critical to success than rigidly defined workflows or fancy software tools. If the process gets in the way of people talking to each other and solving problems, the process should change. Why it matters: software is built by people, for people. Complex problems are best solved through direct, dynamic human interaction, not through layers of formal documentation or isolated work. Reliance on rigid processes can stifle creativity, slow down decision-making, and create bottlenecks. 2. Working software over comprehensive documentation. What it means: the ultimate measure of progress in software development is not the amount of documentation produced, but functioning software that delivers value to the customer. While some documentation is valuable and necessary, e.g., to understand complex system architecture, user guides, the focus should be on building and delivering tangible, usable features. Why it matters: in rapidly changing environments, extensive documentation efforts can quickly become outdated, costly to maintain, and delay the delivery of actual value. Customers don't pay for documents. They pay for software that solves their problems. Working software provides concrete feedback, allowing teams to validate assumptions and course-correct quickly. 3. Customer collaboration over contract negotiation. What it means: rather than relying solely on a formal contract established at the beginning of a project, Agile advocates for continuous, active collaboration with the customer throughout the development lifecycle. This means frequent engagement, gathering ongoing feedback, and adapting to their evolving needs. Why it matters: requirements in software are rarely static. A contract, by its nature, tries to lock down scope and features early on. But if the market shifts or the customer discovers a new need, rigidly sticking to the contract can lead to a product that is technically done, but commercially irrelevant. Continuous collaboration ensures the software remains aligned with the customer's true, emerging needs. 4. Responding to change over following a plan. What it means: this value acknowledges that in the dynamic world of software, change is inevitable and often beneficial. Instead of trying to create an exhaustive, unchangeable plan upfront and rigidly adhering to it, Agile teams embrace change as an opportunity to deliver better results. Plans are important guides, but they are subject to adaptation based on learning and new information. Why it matters. Trying to suppress change makes a project brittle and expensive. Early detection of changes and the ability to adapt quickly allow teams to pivot, innovate, and deliver a more valuable product. This requires flexibility and a culture that views change as a competitive advantage rather than a disruption. 4.3. The 12 principles behind the Agile Manifesto. To further elaborate on the 4 values, the Agile Manifesto also included 12 supporting principles. These principles provide more concrete guidance on how to implement the Agile mindset. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. Emphasizes customer satisfaction and frequent delivery. Welcome changing requirements, even late in development. Agile processes harness change for the customer's competitive advantage. Reinforces adaptability. Deliver working software frequently, from a couple of weeks to a couple of months, with a preference to the shorter timescale. Promotes short cycles and tangible output. Business people and developers must work together daily throughout the project. Underscores collaboration and constant communication. Build projects around motivated individuals. Give them the environment and support they need, and trust them to get the job done. Focuses on empowerment and trust. The most efficient and effective method of conveying information to and within a development team is face-to-face conversation. Highlights the power of direct interaction. Working software is the primary measure of progress. Reiterates the value of tangible output. Agile processes promote sustainable development. The sponsors, developers, and users should be able to maintain a constant pace indefinitely. Advocates for work-life balance and long-term viability. Continuous attention to technical excellence and good design enhances agility. Recognizes that good craftsmanship prevents technical debt and allows for future flexibility. 10. Simplicity, the art of maximizing the amount of work not done, is essential. Encourages focus on core value and avoiding unnecessary complexity. 11. The best architectures, requirements, and designs emerge from self-organizing teams. Trusts empowered teams to find optimal solutions. 12. At regular intervals, the team reflects on how to become more effective, then tunes and adjusts its behavior accordingly. Embodies continuous improvement and adaptation, the retrospective. These principles provide a compass for teams and organizations aiming to become more agile, guiding their practices and decision-making far beyond any specific methodology. 4.4. The Agile Mindset. More than just practices, it's crucial to understand that Agile is not merely a set of tools or a rigid process to be blindly followed. It is, at its core, a mindset, a way of thinking about how work should be done. Teams that adopt Agile practices without internalizing the Agile mindset often find themselves merely doing Agile in name only or Agile but, Scrum but, Kanban but, without realizing the full benefits. The Agile mindset embodies several key aspects: empiricism, learning by doing and adapting based on observed results. This involves cycles of inspection and adaptation. Transparency, making work visible and progress clear to everyone involved. Collaboration, working together across functions and with customers. Self-organization, empowering teams to decide how best to accomplish their work. Continuous improvement, always looking for ways to become more effective. Value-driven, focus on delivering the highest possible value to the customer. Psychological safety, creating an environment where individuals feel safe to voice ideas, concerns, and even failures, knowing they won't be punished. Developing an Agile mindset requires a significant cultural shift for many organizations, moving from command and control structures to environments that foster trust, autonomy, and continuous learning. It prioritizes adapting to reality over adhering to a static plan. 4.5. The broad benefits of embracing Agile. Since its inception, the Agile movement has delivered significant benefits to countless organizations across various industries. Faster time to market. By delivering working software in smaller, frequent increments, products reach users sooner, allowing organizations to capitalize on opportunities rapidly. Increased customer satisfaction. Continuous collaboration and feedback loops ensure that the product evolves to meet true customer needs, leading to higher adoption and satisfaction. Improved product quality. Regular testing, continuous integration, and frequent iterations allow for earlier detection and resolution of defects, resulting in more robust and reliable software. Enhanced team morale and productivity. Empowered, self-organizing teams often report higher job satisfaction, stronger collaboration, and greater ownership of their work, leading to increased productivity. Better adaptability to change. The ability to pivot quickly in response to market shifts or new information provides a significant competitive advantage. Reduced risk. By delivering in small increments and receiving regular feedback, major problems or misalignments are identified and corrected early, mitigating large-scale failures. Greater transparency. Agile practices, like daily stand-ups and visible backlogs, make progress, impediments, and priorities clear to the entire team and stakeholders. These benefits demonstrate why Agile has moved beyond just software development and has influenced project management practices across many other domains, from marketing to manufacturing. 4.6 Common misconceptions and anti-patterns of Agile. Despite its widespread adoption, Agile is frequently misunderstood or misapplied, leading to what are often called Agile anti-patterns. Understanding these helps clarify what Agile isn't. Agile doesn't mean no plan or chaos. Agile is not about throwing out planning. It's about adaptive planning just enough, just in time, and continuously refining the plan based on new information. Chaos is the opposite of Agile. Agile doesn't mean no documentation. The manifesto values working software over comprehensive documentation, not no documentation. Teams still produce necessary documentation, e.g., user stories, architecture diagrams, release notes, but it's focused on delivering value and kept concise. Agile doesn't negate the need for technical excellence. Some misinterpret Agile as a license to cut corners and deliver quick and dirty code. On the contrary, Principle 9 explicitly calls for continuous attention to technical excellence and good design. Poor code leads to technical debt, which ultimately hinders agility. Agile isn't just for development teams. While it originated in software, Agile's principles about collaboration, adaptation, and continuous improvement are applicable across many functions, from business analysis to marketing. It requires buy-in and participation from stakeholders outside the immediate development team. Agile is not a silver bullet. Agile is a mindset and a set of principles that can lead to better outcomes. It's not a magical solution that fixes all problems instantly. Successful adoption requires discipline, continuous effort, and a willingness to change organizational culture. Understanding these misconceptions is vital for anyone embarking on an Agile journey. The true power of Agile lies in its core values and principles, which we will continue to explore as we dive into specific Agile frameworks like Scrum and Kanban in the following chapters. Chapter 5, Scrum, the heartbeat of Agile teams. 5.1 What is Scrum? A lightweight framework for complexity. If the Agile Manifesto provides the guiding philosophy, Scrum is one of the most popular and widely adopted frameworks for implementing that philosophy in software development and beyond. It's a lightweight, iterative, and incremental framework designed to help teams deliver value in short cycles, handle complex adaptive problems, and constantly improve their products and processes. The term Scrum was first used in a 1986 Harvard Business Review article, The New Product Development Game, by Hirotaka Takeuchi and Ikujiro Nanaka. They likened highly efficient, holistic product development to the Scrum formation in rugby, where the entire team works together to move the ball forward. Building on this idea, Ken Schwaber and Jeff Sutherland co-created what is now known as the Scrum framework in the early 1990s, later codifying it in the Scrum Guide. Scrum is not a prescriptive, step-by-step methodology like Waterfall. Instead, it provides a flexible framework built on empiricism, the idea that knowledge comes from experience and making decisions based on what is observed. It emphasizes transparency, inspection, and adaptation. Within Scrum, Teams operate in short, time-boxed iterations called sprints, typically lasting 1 to 4 weeks. During each sprint, a cross-functional team works to produce a done, potentially shippable increment of valuable product. The beauty of Scrum lies in its simplicity and its focus on fostering communication, self-organization, and rapid feedback loops. It pushes complexity to the edges, allowing teams to focus on delivering the highest value features in a highly adaptive manner. 5.2 The 3 roles of Scrum. Product Owner, Scrum Master, Development Team. Scrum defines a small, self-organizing, and cross-functional team structure designed to maximize communication and minimize overhead. There are only 3 specific roles in a Scrum team. The Product Owner. This individual is the central figure responsible for maximizing the value of the product resulting from the work of the development team. They are the voice of the customer and the key stakeholder representative. Their main responsibilities include clearly articulating the product goal and managing the product backlog, a prioritized list of all the features, functionalities, and fixes needed for the product, ensuring that product backlog items are clearly expressed, understandable, and adequately detailed, ordering product backlog items to best achieve goals and missions, ensuring the product backlog is visible, transparent, and understood by everyone, regularly inspecting and adapting the product backlog based on feedback and new insights. The product owner is one person, not a committee, ensuring a single point of accountability for product vision and prioritization. The Scrum Master. This is the team's facilitator, coach, and protector. They are a servant leader who ensures that the Scrum team understands and adheres to Scrum theory, practices, and rules. Their responsibilities include coaching the development team in self-organization and cross-functionality, helping the product owner manage the product backlog effectively, facilitating Scrum events as needed, removing impediments, obstacles that hinder the development team's progress, coaching and guiding the organization in its adoption of Scrum, sometimes advocating for changes in the wider organizational structure to optimize the Scrum team's effectiveness. The Scrum Master isn't a project manager in the traditional sense. They don't assign tasks or dictate how work is done, but rather enable the team to be effective. The development team. This consists of the professionals who do the work of delivering a done increment each sprint. The development team is self-organizing. They decide how best to accomplish their work. And cross-functional, they have all the skills necessary to turn product backlog items into a working product without relying on outside specialists. Their responsibilities include creating a plan for the sprint backlog, turning product backlog items into a done increment during the sprint, adapting their plan each day toward the sprint goal, holding each other accountable as professionals. There are no sub-teams or individual titles for members within the development team, e.g., developer, tester, designer. Everyone is simply a developer in Scrum, emphasizing shared responsibility for the outcome. The ideal size for a development team is typically 3 to 9 members, excluding the product owner and Scrum Master. 5.3 The 5 events of Scrum. Sprint, sprint planning, daily Scrum, sprint review, sprint retrospective. Scrum prescribes a series of time-boxed events, each with a specific purpose, to create regularity and minimize the need for external meetings. These events ensure transparency and provide opportunities for inspection and adaptation. The sprint. This is the heartbeat of Scrum, a time box of 1 to 4 weeks during which a done, usable, and potentially releasable product increment is created. Sprints are consistent in duration throughout a development effort. Each sprint starts immediately after the conclusion of the previous sprint. During a sprint, no changes are made that would endanger the sprint goal. Quality goals do not decrease. The scope may be clarified and renegotiated with the product owner as more is learned. Sprint planning kicks off the sprint. The entire Scrum team collaborates to lay out the work for the upcoming sprint. It answers the following questions: why is this sprint valuable? Defines the sprint goal. What can be done in this sprint? Selects items from the product backlog to create the sprint backlog. How will the chosen work get done? The development team plans the work needed to deliver the selected items. This event is time-boxed to a maximum of 8 hours for a 1-month sprint. Daily Scrum, Daily Stand-Up, a 15-minute time-boxed event for the development team. It's a key inspect and adapt meeting that occurs daily at the same time and place. Its purpose is to inspect progress toward the sprint goal and adapt the sprint backlog as necessary, adjusting the upcoming planned work. It's not a status meeting for the Scrum Master or product owner, but a planning meeting for the development team to synchronize activities and plan for the next 24 hours. Sprint Review, held at the end of the sprint to inspect the increment and adapt the product backlog if needed. The Scrum team presents the results of their work to key stakeholders, and collaboration occurs on what to do next. It's an informal meeting, not a gate, and the presentation of the increment is intended to elicit feedback and foster collaboration. It's time-boxed to a maximum of 4 hours for a 1-month sprint. Sprint Retrospective occurs after the sprint review and before the next sprint planning. The purpose of the retrospective is for the Scrum team to inspect how the last sprint went with regards to individuals, interactions, processes, and tools. The team identifies what went well, what could be improved, and creates a plan for improvements to be enacted in the next sprint. This fosters continuous improvement for the team itself. It's time-boxed to a maximum of 3 hours for a 1-month sprint. 5.4 The 3 artifacts of Scrum: Product Backlog, Sprint Backlog, Increment. Scrum's artifacts are designed to maximize transparency of key information. They represent work or value. Product Backlog. This is an ordered list of everything that might be needed in the product. It is the single, authoritative source of work to be done. It lists features, functions, requirements, enhancements, and fixes. The product backlog is dynamic, constantly evolving, and belongs to the product owner. Items at the top are usually clearer and more detailed. Sprint Backlog. This is a set of product backlog items selected for the sprint, plus a plan for delivering the increment and realizing the sprint goal. It is created by the development team during sprint planning. It makes visible all the work the development team identifies as necessary to meet the sprint goal. The sprint backlog is owned by the development team and is a highly visible, real-time picture of the work that remains to be done in the sprint. Increment. This is the sum of all the product backlog items done during a sprint and the value of the increments of all previous sprints. It must be done, meaning it is in a usable condition and meets the development team's definition of done, which we'll discuss next. It means no more work is needed on it. The increment is a step toward a vision or goal. It must be potentially shippable, regardless of whether the product owner chooses to release it. 5.5 Key Scrum Concepts. Definition of done, do, time boxing, empiricism. Beyond the roles, events, and artifacts, several core concepts underpin Scrum's effectiveness. Definition of done, do. This is a shared understanding within the Scrum team of what it means for work to be complete. It's a checklist of quality criteria that all increment items must satisfy before they can be considered done. For example, it might include code reviewed, unit tested, integrated, passes all acceptance tests, documented, and deployed to staging. The do creates transparency and ensures that what is assumed to be done is truly ready for potential release, minimizing hidden work and ensuring quality. Time boxing. All Scrum events are time-boxed, meaning they have a maximum duration. Once a time box is over, the event ends regardless of whether all agenda items have been discussed. This ensures focus, encourages efficiency, and prevents endless meetings. It provides structure without being overly prescriptive about how the work within the time box is done. Empiricism. Scrum is founded on the pillars of empiricism. Transparency. Significant aspects of the process must be visible to those responsible for the outcome. Inspection. Scrum teams and stakeholders regularly inspect Scrum artifacts and progress toward a sprint goal to detect undesirable variances. Adaptation. If an inspector determines that one or more aspects of a process deviate outside acceptable limits, the process or the material being processed must be adjusted. These 3 pillars provide the ongoing feedback loops that allow Scrum teams to continuously learn and improve. 5.6 Strengths and Weaknesses of Scrum. Strengths: rapid adaptation to change. The short sprints and frequent feedback loops enable teams to quickly adapt to changing requirements and market conditions, delivering what the customer truly needs. Increased transparency. The roles, events, and artifacts make progress, impediments, and decisions highly visible to everyone involved. Improved team collaboration and morale. Self-organizing, cross-functional teams foster strong collaboration, shared ownership, and a sense of empowerment. Frequent delivery of value. Producing a done increment every sprint ensures that tangible, working software is regularly delivered, providing early returns on investment. Enhanced risk management. By breaking down work into small chunks and regularly inspecting progress, risks are identified and mitigated early. Weaknesses and common challenges. Requires dedicated roles. For Scrum to work effectively, the product owner and Scrum Master roles require significant dedication and appropriate individuals, which can be challenging for organizations to provide. Intense collaboration and communication. While a strength, it can be challenging for distributed teams or organizations with a culture of siloed work. Scrumboot implementations. Many organizations adopt the mechanics of Scrum, e.g., daily scrums, sprints, without truly understanding and embracing the underlying Agile mindset and principles. This leads to ineffective implementations that provide little benefit. Can struggle with very large projects. While frameworks exist to scale Scrum, which we'll touch on later, pure Scrum itself is designed for single, relatively small teams. Orchestrating many Scrum teams without additional layers or frameworks can be complex. Requires a culture of trust and empowerment. Moving from a command and control hierarchical structure to a self-organizing team paradigm requires significant organizational and cultural change that can be difficult to achieve. 5.7 Case Study. Implementing Scrum in a dynamic startup or enterprise setting. Case study, InnovateTech startup rescues product with Scrum. InnovateTech, a fast-growing tech startup, was developing a new AI-powered analytics platform. Initially, they operated with a loose code-and-fix approach. Their first release was significantly delayed, full of bugs, and missed key market features because requirements kept changing. The team was frustrated, and investor confidence was waning. The shift to Scrum, their CTO, newly onboarded and having previous Agile experience, decided to implement Scrum as an emergency measure. They formed 2 cross-functional Scrum teams of 7 to 8 people each. Product owner. A dedicated product manager was assigned as the product owner for each team, with one also acting as a super product owner coordinating across products. They immediately started working with early customers to build a robust product backlog, focusing on the most critical features for an MVP. Scrum Master. An experienced team lead transitioned into the Scrum Master role, coaching the teams on Scrum events and principles and relentlessly removing impediments. Development teams. Existing developers, designers, and QA engineers were reorganized into self-organizing teams. Results. Shortened release cycles. They moved from vague 6-month release targets to concrete 2-week sprints, delivering usable software often. Improved communication, daily scrums and co-location, or dedicated video calls for remote members, significantly improved internal team communication. Sprint reviews brought stakeholders closer, providing rapid feedback. Higher quality, regular reviews, and a strong definition of done for each sprint increment meant fewer bugs made it to production. Increased adaptability. When a major competitor announced a similar feature, the product owner could quickly reprioritize the product backlog, and the team could pivot within the next sprint, rather than being stuck with a long-term, unchangeable plan. Boosted morale. Developers felt more engaged, empowered, and saw the direct impact of their work hitting users quickly. Within 6 months, InnovateTech was consistently hitting their sprint goals, delivering valuable features, and had significantly improved their product's market position, largely due to the transparency, fast feedback, and disciplined prioritization brought by Scrum. While they faced initial challenges with cultural shifts and getting used to the new rhythms, the commitment to Scrum helped them navigate complexity and respond dynamically to customer and market needs. Scrum stands as a testament to the power of structured empiricism and collaborative teamwork in tackling the complexities of modern software development. While it requires commitment and a willingness to change, its proven ability to deliver value frequently and adapt rapidly makes it a cornerstone of the Agile world. Chapter 6, Kanban, Visualizing Flow for Efficiency. 6.1 Kanban's Origins. From Toyota Production System to software development. While Scrum often gets the spotlight in Agile discussions, Kanban offers a powerful, alternative approach deeply rooted in principles of continuous improvement and flow. Its origins are not in software development, but in the highly efficient manufacturing processes of the automotive industry, specifically the Toyota Production System, TPS. In the late 1940s, Toyota engineer Taiichi Ono developed Kanban, Japanese for visual signal or card, as a scheduling system for just-in-time JIT manufacturing. The goal was to improve efficiency by reducing waste and optimizing workflow. Instead of producing goods based on forecasts and pushing them through the production line, Kanban created a pull system. When a finished product was sold, a Kanban card, would be sent back to the previous station, authorizing it to produce just enough to replace what was consumed. This ensured that production was directly tied to market demand, minimizing overproduction, inventory, and other forms of waste. Decades later, the principles of Kanban were recognized as highly applicable to knowledge work, including software development. David J. Anderson is credited with formally adapting Kanban for IT and software development in the mid-2000s, realizing that the flow of tasks in software creation could be managed much like the flow of physical goods on a factory floor. The core idea remained the same: visualize work, limit work in progress, and manage flow to deliver value more efficiently. 6.2 The core principles of Kanban. Evolutionary change and starting where you are. Unlike Scrum, Kanban is not a prescriptive framework with defined roles or specific events. It's more of a method that helps optimize any existing process by applying a set of core principles and practices. This makes Kanban incredibly adaptable and often less disruptive to implement initially. The two foundational principles of Kanban are: start with what you do now. Kanban emphasizes working with your existing process, roles, and responsibilities. It doesn't require a radical, upfront change. Instead, it aims to incrementally improve the current system. This makes adoption less intimidating and allows teams to evolve their process over time. Agree to pursue evolutionary change. Kanban encourages continuous, small, incremental improvements rather than requiring large, revolutionary transformations. This reduces resistance and allows for a smoother transition to a more efficient workflow. The idea is to make small adjustments, observe their impact, and then make further adjustments based on that learning. These foundational principles highlight Kanban's flexible, non-disruptive nature, making it a good fit for teams looking to improve their existing operations without a complete overhaul. 6.3 The 6 core practices of Kanban. Making flow visible. To implement the principles, Kanban relies on 6 core practices. Visualize the workflow. This is the cornerstone of Kanban. All work items and workflow stages are made explicitly visible. This typically involves a Kanban board, a physical or digital tool where work items are represented as cards and columns represent the stages of the workflow. Visualization brings transparency, highlights bottlenecks, and creates a shared understanding of how work moves through the system. Limit work in process, WIP. This is perhaps the most crucial practice. A WIP limit restricts the number of items that can be in any given stage of the workflow at any one time. When a column hits its WIP limit, no new work items can be pulled into that stage until an existing item moves to the next stage. This forces the team to focus on completing work rather than starting new work, drastically reducing multitasking, context switching, and improving throughput. It creates a pull system where work is only pulled into a stage when there is capacity. Manage flow. Once WIP limits are in place, the team focuses on managing and optimizing the flow of work. This involves identifying and addressing bottlenecks, reducing lead times, the time it takes for a work item to go from start to finish, and ensuring a smooth, predictable delivery of value. Flow is measured, monitored, and continuously improved. Make process policies explicit. For work to flow smoothly and predictably, everyone needs to understand the rules of the road. Explicit policies define when a work item moves from one column to the next, e.g., development done means it has passed unit tests and code review. These policies should be visual, easily accessible, and agreed upon by the team. Implement feedback loops. Just like in Scrum, regular feedback loops are essential for continuous improvement. This can include daily stand-ups, often called Kanban meetings, where the focus is on the flow of work, moving from right to left on the board, service delivery reviews, and operations reviews. The goal is to frequently inspect the process and adapt, improve collaboratively, evolve experimentally. Kanban emphasizes continuous improvement through collaborative discussion and experimental change. Teams use data, metrics on flow, and observation to identify areas for improvement, propose changes, implement them as experiments, and measure their impact. This data-driven, evolutionary approach fosters a culture of continuous learning. 6.4 The Kanban Board, your workflow at a glance. The most recognizable element of Kanban is the Kanban board. It's a visual information radiator that helps teams manage their workflow by providing a clear, real-time overview of all active work. A typical Kanban board consists of columns. Each column represents a distinct stage in the workflow. Common stages in a software development context might include backlog, ready for development, in development, code review, testing, ready for release, and done. Cards. Each card represents a single work item, e.g., a user story, a bug fix, a task. Cards typically contain a brief description of the work, assignee, and other relevant information. As work progresses, cards move from left to right across the board. WIP limits. Numbers placed at the top of each column, excluding backlog and done, indicate the maximum number of cards allowed in that stage at any given time. These limits are crucial for creating the pull system. Swim lanes, optional. Horizontal rows can be used to categorize work items, e.g., by project, type of work like expedite or standard or team. How it works, the pull system. Instead of work being pushed through the system, in Kanban, work is pulled. When a team member finishes a task in one column, they pull the next available task from the preceding column, provided that column is within its WIP limit. If a column is blocked, e.g., due to a WIP limit being reached in the next stage, the team focuses on unblocking that work first, rather than starting new work. This laser focus on completing work and clearing bottlenecks is what makes Kanban so efficient. For example, if the testing column has a WIP limit of 3, and there are already 3 cards in it, the code review stage cannot pass any more completed items to testing until one of the current 3 items moves out of testing into ready for release. This compels developers to help testers or to address blocking issues rather than starting a new feature. 6.5 Metrics that matter in Kanban. Lead time, cycle time, throughput, flow efficiency. Kanban is inherently data-driven. By visualizing flow and imposing WIP limits, teams can gather valuable metrics to understand their performance and identify areas for improvement. Lead time. This is the total time it takes for a work item to go from the moment a customer requests it or it enters the backlog to the moment it is delivered to the customer. It measures the end-to-end delivery performance. Cycle time. This is the duration a work item spends actively moving through the workflow, from when it starts being worked on to when it is delivered. It typically excludes the time spent waiting in the initial backlog. Reducing cycle time is a primary goal in Kanban, as it means work is flowing faster. Throughput. This is the number of work items completed within a specific time period, e.g., per week, per month. It measures the rate at which value is delivered. Flow efficiency. This metric calculates the ratio of active work time, time spent actually working on a task, to total cycle time, including waiting time. A low flow efficiency indicates a lot of time is spent waiting or being blocked, highlighting areas for process improvement. These metrics provide objective data points for the team to inspect their process, identify inefficiencies, and measure the impact of their evolutionary changes. 6.6 Kanban strengths and weaknesses. Strengths, non-disruptive adoption. Its start with what you do now principle makes it less intimidating to implement. allowing for gradual, evolutionary change without requiring a complete overhaul of existing roles or processes. Flexibility and adaptability. Kanban is highly flexible, supporting different types of work and adapting to various organizational structures. It's excellent for processes with highly variable work items and priorities. Flow and efficiency focus. By limiting WIP and visualizing bottlenecks, Kanban excels at improving the flow of work, reducing lead times, and significantly increasing throughput. It helps optimize existing workflows. Reduced multitasking and context switching. WIP limits force teams to focus on finishing tasks before starting new ones, leading to improved concentration and efficiency. Continuous delivery. Kanban inherently supports continuous delivery by focusing on smooth, continuous flow rather than fixed release cycles. It allows features to be released as soon as they are done. Transparency and visibility. The Kanban board provides a real-time, highly visual overview of work in progress, bottlenecks, and team status. Weaknesses and common challenges. Less prescriptive structure. Unlike Scrum, Kanban doesn't define roles, events, or artifacts. This can be a strength for experienced teams, but a weakness for teams new to Agile who might need more guidance. Requires discipline with WIP limits. The power of Kanban hinges on strictly adhering to WIP limits. Without this discipline, the board can become a mere task tracking tool, losing its effectiveness in managing flow. Potential for lack of focus without a clear product goal. While flexible, without a strong product vision or clear prioritization mechanism, which Kanban doesn't prescribe, a team might optimize the flow of less important work. Cultural challenges to lean principles. Implementing WIP limits often exposes underlying organizational issues, e.g., resource dependencies, constant prioritization changes, lack of skilled staff. Addressing these can be culturally challenging. Less emphasis on self-organizing teams, initially. While it encourages collaboration, Kanban doesn't explicitly mandate self-organizing teams with cross-functional roles in the same way Scrum does. Its emphasis is more on process optimization first. 6.7 Case Study. Using Kanban for service delivery and continuous flow. Case study. SupportStream improves customer support efficiency with Kanban. SupportStream is a company providing B2B SaaS solutions, and their customer support and bug fixing team was consistently swamped. Urgent issues would frequently interrupt ongoing work, leading to slow response times, frustrated customers, and burned-out engineers who were constantly context switching. They handled a mix of emergency bugs, smaller feature requests from customers, and knowledge base updates. The shift to Kanban, the SupportStream leadership decided to implement Kanban. Visualize workflow. They created a digital Kanban board with columns: inbox, new requests; analysis, in progress, bug fix; in progress, feature request; awaiting QA, ready for deployment, done. WIP limits. Crucially, they introduced WIP limits. For in-progress bug fix, they set a limit of 2, and in-progress feature request to 3. Analysis was limited to 5. Explicit policies. They defined policies for moving cards. For example, a bug fix could only move from analysis to in progress if the bug was fully reproduced and understood. Swim lanes. They added swim lanes for expedite, critical outages, and standard, regular bug fixes features. Expedite lanes had lower or no WIP limits to signify immediate attention required. Frequent synchronization. While not daily stand-ups in the Scrum sense, they held short, daily Kanban meetings, walking the board from right to left, asking what's blocking this item from moving to done. Results: reduced lead time for critical issues. By visualizing, expedite, items, and prioritizing WIP limits, critical bugs were resolved much faster. Improved throughput. By reducing multitasking WIP limits, engineers became more focused, leading to an increase in the number of tasks completed per week. Increased predictability. Customer service representatives could give more accurate estimates on when issues would be resolved, improving customer satisfaction. They understood why new work couldn't be started immediately. Identified bottlenecks. The board frequently highlighted the analysis, and awaiting QA columns often hitting their WIP limits, indicating a need for more resources or better processes in those stages, leading to targeted improvements. Less stress. The team felt less overwhelmed by the sheer volume of work because they could see the flow and were focused on one thing at a time. Kanban proved to be an excellent fit for support stream because their work was interrupt-driven and highly varied. It didn't force them into fixed iterations like Scrum, but rather helped them optimize their existing, continuous flow of work. It demonstrated that by simply visualizing work and limiting the amount of work in progress, significant improvements in efficiency, predictability, and stress levels can be achieved. Chapter 7, Less Waste, More Value, Lean Software Development. 7.1, The Roots of Lean, the Toyota Production System and Lean Manufacturing. Just like Kanban, the principles of lean software development trace their lineage back to the revolutionary manufacturing philosophy of the Toyota Production System, TPS, developed by Toyota in the mid-20th century. TPS focused relentlessly on optimizing production by systematically identifying and eliminating waste, muter in Japanese, while simultaneously improving quality and efficiency. It sought to create a pull system where production was triggered by demand, rather than a push system, which often led to overproduction and stockpiles of inventory. Key concepts from TPS that laid the groundwork for lean include just-in-time JIT, producing only what is needed when it is needed in the amount needed. This minimizes inventory and reduces wasted resources. Jidoka, automation with a human touch, building quality into the process, allowing machines to stop automatically when a defect is detected, preventing the spread of errors. Kaizen, continuous improvement, a philosophy of constantly seeking small, incremental improvements in all processes. Value stream mapping, identifying all the steps in a process and analyzing which add value and which are waste. In the early 2000s, Mary Poppendike and Tom Poppendike authored a series of influential books that specifically applied these lean manufacturing principles to the world of software development. They recognized that the challenges faced by software teams, long lead times, accumulated technical debt, features that didn't meet customer needs, had parallels to the waste seen in traditional manufacturing. Their work helped formalize the concept of lean software development. 7.2, The 7 Lean Principles of Software Development. The Poppendikes distilled the core ideas of lean into 7 key principles directly applicable to software development. Eliminate waste. This is the foundational principle. In software, waste, muta, is anything that does not add value to the customer or the product. Common types of waste in software development include partially done work, code that is written but not yet deployed, extra processes, unnecessary approvals, excessive documentation, redundant meetings. Extra features, building features that are not used or do not provide significant customer value. Task switching, context switching, the cost of moving between different projects or tasks. Waiting, delays caused by dependencies, approvals, or lack of resources. Defects, bugs and errors that require rework. Motion, unnecessary movement of information or people. The goal is to identify these forms of waste and eliminate them to streamline the value stream. Amplify learning. Software development is a learning process. Features often start as hypotheses, and teams learn whether those hypotheses are correct by getting working software into users' hands. Lean advocates for frequent feedback loops, short iterations, rapid prototyping, and empirical observation to continuously learn and adapt. The faster a team can learn, the faster they can deliver the right product. Decide as late as possible, also known as last responsible moment, LRM. This principle advises against making irreversible decisions too early, particularly when information is still limited or uncertain. Instead, keep options open, deferring commitments until the last possible moment when more information is available. This allows decisions to be based on the latest knowledge and market conditions, rather than on potentially outdated assumptions. Deliver as fast as possible. Speed is crucial for 2 main reasons. Time to market. Getting features into customers' hands quickly allows for early feedback and captures market opportunities. Reduced risk. Shorter cycles limit complexity and the potential for errors, making it easier to identify and fix issues. This principle encourages continuous delivery, small batch sizes, and optimized workflows to maximize throughput. Empower the team. Lean recognizes that the people doing the work are often in the best position to identify problems and propose solutions. It advocates for delegating decision-making to the development teams, fostering self-organization, and providing the tools and environment they need to succeed. Trusting individuals and letting them manage themselves leads to higher motivation, better solutions, and increased accountability. Build integrity in. This principle covers both perceived integrity, how well the software works from the user's perspective, like usability and consistency, and conceptual integrity, the internal coherence, consistency, and clean architecture of the code. It emphasizes designing for quality from the outset, investing in good architecture, automation, and continuous testing to prevent defects rather than fixing them later. This minimizes technical debt and maintains long-term agility. See the whole? This principle emphasizes taking a holistic view of the entire value stream, from initial customer request to deployed software and ongoing support. Optimizing a single part of the process in isolation might not improve the overall flow and could even create new bottlenecks elsewhere. Understanding the entire system and ensuring components work well together is essential for true efficiency. Value stream mapping is a key tool used to achieve this principle. 7.3. How Lean influences Agile and modern development. Lean principles have profoundly influenced the entire Agile movement and continue to shape modern software development practices. In many ways, Lean provides the underlying philosophical engine for many Agile frameworks. Scrum's empiricism. The inspect and adapt cycles in Scrum directly reflect Lean's amplify learning and continuous improvement principles, focusing on learning from actual results. Kanban's flow and WIP limits. Kanban's entire methodology, particularly its focus on visualizing waste, limiting work in progress, and managing flow, is a direct application of Lean's eliminate waste and deliver as fast as possible principles. Minimum viable product, MVP. This widely used concept, where a product is launched with only essential features to learn from early users, is a perfect embodiment of amplify learning and deliver as fast as possible. Continuous integration, continuous delivery, CI/CD. These practices, central to modern software delivery, are direct applications of deliver as fast as possible and build integrity in by automating testing and deployment to reduce waste and accelerate feedback. Test-driven development, TDD, and refactoring. These practices, often associated with extreme programming, but aligned with Lean, reflect build integrity in by promoting constant vigilance over code quality and design. DevOps culture. The focus on breaking down silos, automating processes, and feedback loops in DevOps is heavily influenced by Lean's see the whole and eliminate waste principles. Lean principles provide a robust mental model for how to think about optimizing any value creation process, making them incredibly versatile and influential across the software development landscape. 7.4. Practical application of Lean principles in software teams. Applying Lean principles doesn't necessarily mean adopting a specific framework. It means ingraining a continuous improvement mindset. Here are some practical ways teams can apply Lean. Value stream mapping. Conduct workshops to map out the entire process of delivering software, from ideation to production. Identify every step, its duration, and whether it adds value. This visually highlights delays, rework loops, and unnecessary steps. Waste. Batch size reduction. Break down large features or tasks into smaller, manageable chunks. Smaller batches flow through the system faster, reduce work in progress, allow for quicker feedback, and make problems more visible sooner. Automation. Automate repetitive manual tasks, such as testing, builds, and deployments. This eliminates waiting times, reduces human error defects, and dramatically increases delivery speed. Visual management. Use visual tools like Kanban boards, physical or digital, to make work visible, track progress, identify bottlenecks, and make process policies explicit. Empowerment and cross-functional teams. Foster an environment where teams can self-organize, make decisions, and take ownership of their work. Encourage cross-functional teams that have all the skills needed to complete work from start to finish without external dependencies. Focus on done. Implement a robust definition of done to ensure that what is considered complete is truly ready for use, reducing partial done work and ensuring quality. A continuous improvement culture. Regularly hold retrospectives or process improvement meetings, like Kanban's service delivery review, to reflect on how the process is working, identify areas for improvement, and experiment with changes. Eliminate handoffs. Every time work is handed off between individuals or teams, there's a risk of miscommunication, delay, and quality degradation. Streamline workflows to reduce handoffs. 7.5 Benefits and challenges of adopting a lean mindset. Benefits: increased efficiency and speed. Ruthless elimination of waste directly translates to faster delivery times and higher throughput. Higher quality products. By building quality in Jidoka and reducing defects, the end product is more reliable and robust. Improved responsiveness. Faster learning cycles and delivery speed enable teams to respond quickly to market changes and customer feedback. Cost reduction. Eliminating waste, rework, and unnecessary features directly saves resources and money. Enhanced team morale. Empowering teams, removing impediments, and streamlining workflows can lead to a more satisfying and less frustrating work environment. Clearer focus on value. By constantly asking, does this add value to the customer? Teams ensure they are working on what truly matters. Challenges require strong cultural change. Moving from a traditional, siloed organization to a lean, end-to-end value stream mindset requires significant cultural transformation, often facing resistance from management and employees. Difficulty in identifying all waste. Some forms of waste, e.g., intellectual waste from disengaged employees, are subtle and hard to quantify. Focus on process optimization. While lean principles can improve outcomes significantly, they don't inherently provide a specific product vision or strong requirements management mechanism like Scrum does with a product owner. Fear of loss of control. Managers accustomed to traditional command and control structures may struggle with empowering teams and delegating decision-making. Initial investment in automation. While automation ultimately saves money, the initial setup and maintenance can require an investment in tools and training. Ultimately, lean software development is less about adopting a prescribed set of rules and more about cultivating a mindset of continuous improvement and relentless waste elimination. By focusing on delivering value efficiently and learning continuously, organizations can build software that is not only robust and high quality, but also consistently meets the evolving needs of their customers. It provides a powerful lens through which to view and optimize any software development process. Chapter 8. Bridging the Divide, the Rise of DevOps. 8.1 The Problem. The DevOps Divide and the Software Delivery Bottleneck. For decades, a significant chasm existed between software development, dev, teams, and IT operations, ops teams. Like two separate kingdoms within the same organization, they often had conflicting goals, different priorities, and distinct cultures, leading to friction and significant bottlenecks in software delivery. Development's goal. Developers are typically focused on innovation, building new features, fixing bugs, and delivering code quickly. They thrive on change and constant iteration. Their mantra is often "ship it." Operations goal. Operations teams, conversely, are focused on stability, reliability, and security. Their priority is to keep systems up and running, ensure smooth performance, and minimize outages. Their mantra is often "nothing changes, nothing breaks." These divergent objectives created a natural tension. Developers would push new code, eager for it to go live. Operations would resist, fearing that new code would introduce instability, bugs, or security vulnerabilities into their carefully managed production environments. This resulted in slow deployments. Releases would be infrequent, often large Big Bang events that required extensive planning, manual handoffs, and rigid change control processes. Blame games. When things went wrong in production, dev would blame ops for not deploying correctly, and ops would blame dev for shipping buggy code. Quality issues. Bugs would often go undetected until they hit production, leading to expensive and time-consuming fixes. Communication gaps. A lack of shared understanding and collaboration between the teams led to misunderstandings and delayed problem resolution. Reduced innovation. The fear of breaking production stifled the quick iteration and experimentation that true innovation requires. This DevOps divide became a major impediment to achieving the speed and agility promised by Agile methodologies. Teams could develop features quickly in sprints, but getting that software into the hands of users remained a slow, painful, and often risky affair. Something fundamental needed to change to bridge this gap. 8.2 What is DevOps? A cultural and technical revolution. DevOps is not a methodology in the same vein as Scrum or Kanban. Rather, it is a cultural and professional movement that integrates software development with IT operations. Its primary goal is to shorten the system's development lifecycle and provide continuous delivery with high software quality. It's about breaking down the walls between dev and ops, fostering collaboration, and automating the entire software delivery pipeline. The common misconception is that DevOps is merely about automation tools. While automation is a critical component, DevOps is fundamentally about culture, people, and processes first. It's about creating a shared sense of responsibility, aligning goals, and fostering a collaborative environment where teams work together from the initial concept to the operational stability of the software in production. DevOps aims to deliver business value faster and more reliably by fostering a culture of collaboration, moving from isolated teams to cross-functional, you build it, you run it, teams where developers care about operations and operations understand development. Automating everything possible. From code builds and testing to infrastructure provisioning and deployments, automation reduces manual effort, speeds up processes, and minimizes human error. Embracing continuous feedback. Monitoring applications in production and feeding insights back to development teams for continuous improvement. It's a synthesis of Agile principles, lean thinking, and a heavy dose of automation and tooling. 8.3 The Pillars of DevOps, CALMS. A widely used acronym to describe the core tenets of DevOps is CALMS. Culture. This is arguably the most important pillar. It emphasizes psychological safety, shared responsibility, trust, transparency, and a blameless post-mortem culture. Instead of finger-pointing, teams collaborate to understand why failures happened and how to prevent them in the future. Automation. This refers to automating repetitive tasks across the entire software delivery pipeline. This includes automated testing, continuous integration, continuous delivery deployment, infrastructure as code, and automated monitoring. Automation reduces manual effort, increases speed, improves consistency, and eliminates human error. Lean. Drawing on lean principles, DevOps focuses on eliminating waste, e.g., waiting times, manual handoffs, excessive documentation, optimizing flow, and maximizing throughput. The goal is to deliver value continuously and in small batches. Measurement. If you can't measure it, you can't improve it. DevOps emphasizes collecting and analyzing data across the delivery pipeline, including lead time, deployment frequency, change failure rate, and mean time to recovery, MTTR. These metrics provide insights into performance and identify bottlenecks for continuous improvement. Sharing. This promotes knowledge sharing, collective learning, and empathy between teams. It involves cross-training, shared tools, common communication channels, and a willingness to learn from successes and failures together. CALMS highlights that DevOps isn't just about what tools you use. It's about a fundamental shift in how people work together and how value flows through the organization. 8.4 Key DevOps Practices. Continuous integration, continuous delivery deployment, infrastructure as code, monitoring, and logging. DevOps leverages several key technical practices that enable its cultural goals. Continuous integration, CI. This practice requires developers to frequently merge their code changes into a central shared repository, typically several times a day. Each merge triggers an automated build process that compiles the code, performs automated tests, unit tests, integration tests, and provides rapid feedback on whether the changes introduced any defects. CI aims to detect integration problems early, preventing large, difficult-to-resolve merge conflicts and bugs. Continuous delivery, CD. Building on CI, continuous delivery ensures that code changes are automatically built, tested, and prepared for release to production. The software is always in a deployable state, meaning it can be released to customers at any time with the push of a button. However, the decision and timing of the actual deployment to production remains a manual choice by a human. Continuous deployment. An extension of continuous delivery, continuous deployment automatically deploys every code change that passes all automated tests and quality gates directly to production. There is no manual intervention. If it passes, it goes live. This is often the ultimate goal for mature DevOps organizations, enabling multiple deployments per day. Infrastructure as code, ISC. Instead of manually provisioning servers, networks, and databases, ISC manages and provisions infrastructure through code, e.g., using tools like Terraform or Ansible. This ensures consistency, repeatability, and allows infrastructure changes to be version-controlled, tested, and deployed just like application code. It accelerates the setup of environments and reduces configuration drift. Monitoring and logging. Comprehensive monitoring and centralized logging are crucial in DevOps. Applications and infrastructure are continuously monitored for performance, health, and security issues. Real-time dashboards, alerts, and detailed logs provide critical insights into how systems are behaving in production, allowing teams to quickly identify and resolve issues and feed usage data back into development cycles for continuous improvement. Automated testing. Moving beyond manual quality assurance, automated testing, unit, integration, system, performance, security tests becomes an integral part of the CI/CD pipeline. This provides rapid feedback on code quality and functionality, allowing developers to catch and fix issues as soon as they arise. 8.5. The DevOps toolchain. Enabling automation. DevOps is enabled by a rich ecosystem of tools across various categories that automate different stages of the software delivery pipeline. While this book won't provide a deep dive into specific products, understanding the types of tools is helpful. Version control systems, Git, and platforms like GitHub, GitLab, Bitbucket for managing and collaborating on code changes. CI/CD automation servers, Jenkins, GitLab CI/CD, Azure DevOps, CircleCI, Travis CI for orchestrating build, test, and deploy pipelines. Containerization and orchestration, Docker for packaging applications and dependencies, Kubernetes for managing and scaling containerized applications. Infrastructure as code tools, Terraform, Ansible, Chef, Puppet, CloudFormation for automating infrastructure provisioning and configuration. Monitoring and logging tools, Prometheus, Grafana, ElkStack, Elasticsearch, Logstash, Kibana, Splunk, Datadog for collecting, visualizing, and analyzing system data. Collaboration tools, Slack, Microsoft Teams, Jira for facilitating communication and tracking work. This integrated toolchain supports the automation and visibility critical for DevOps. 8.6 Benefits of adopting DevOps. Speed, reliability, security, innovation. The benefits of a well-implemented DevOps approach are transformative. Faster delivery cycles. Enables rapid iteration and frequent releases, allowing organizations to respond quickly to market changes and customer feedback. Increased reliability and stability. Automated testing, continuous monitoring, and smaller, more frequent deployments reduce the risk of large-scale failures and make issues easier to pinpoint and fix. Improved quality. Issues are detected and resolved earlier in the development lifecycle, leading to higher quality software in production. Reduced costs. Automation minimizes manual effort, and faster issue resolution reduces the cost of incidents. Enhanced security, DevSecOps. By integrating security practices and testing into every stage of the pipeline, security becomes a shared responsibility, leading to more resilient applications. Better collaboration and communication. Breaking down silos fosters empathy and shared goals between development and operations teams, leading to a more positive work environment. Higher innovation. The ability to experiment, deploy, and learn quickly encourages innovation and reduces the fear of failure. Competitive advantage. Organizations that can deliver value faster and more reliably gain a significant edge in the market. For many companies, DevOps is no longer an option, but a necessity to remain competitive in a world that demands continuous innovation and rapid response. 8.7 Challenges and common pitfalls in DevOps transformation. Despite its compelling benefits, adopting DevOps is a significant undertaking that comes with its own set of challenges. Cultural resistance. The biggest hurdle is usually the organizational culture. Years of siloed work and blame-oriented thinking are hard to change. It requires strong leadership buy-in and a willingness to invest in cultural shifts. Toolchain complexity. Building an integrated DevOps toolchain can be complex, requiring expertise in various technologies and continuous maintenance. Initial investment. While the return on investment is high, the upfront cost in training, new tools, and process changes can be substantial. Skills gap. Teams may lack the necessary skills for automation, security integration, or site reliability engineering, requiring significant training and hiring efforts. Legacy systems. Integrating DevOps practices with outdated legacy systems can be particularly challenging and may require significant refactoring or replatforming. Security concerns. Automating deployments inherently pushes security risks with them. Integrating security effectively, often called DevSecOps, requires careful planning and specialized tools and practices. Misunderstanding DevOps as merely automation. Many organizations mistakenly believe buying a few tools is doing DevOps. Without the cultural shift and integrated processes, automation alone won't yield the desired results. 8.8 Case study. A company's journey to DevOps success. Case study. CloudGen Insurance leverages DevOps for digital transformation. CloudGen Insurance, a traditional, large insurance provider, recognized that their slow, annual software release cycles were hindering their digital transformation efforts. It took months to get a new feature into production, making them unresponsive to market changes and customer demands. Dev and Ops teams largely operated in silos, leading to friction and finger-pointing. Their DevOps journey. CloudGen initiated a multi-year DevOps transformation. Leadership buy-in. The CEO and CIO championed the effort, communicating the vision and providing resources. Cross-functional DevOps squads were formed, integrating developers, QA, and operations engineers. Cultural shift. They started with blameless postmortems after incidents, focusing on systemic issues rather than individual fault. Regular joint training sessions and shared goals for delivery speed and stability were introduced. Automation first. They began automating their build and test processes, then moved to infrastructure provisioning using tools like Terraform and automated deployments with Jenkins. This reduced deployment time for a critical claims application from weeks to hours. Continuous monitoring. They invested in comprehensive monitoring tools, creating shared dashboards visible to both Dev and Ops. This provided real-time insights into application performance in production, allowing them to proactively identify and resolve issues. For example, they spotted a memory leak in a new service before it impacted users, leading to a quick fix. Small batch releases. Instead of large annual releases, they started releasing new features in small, independent batches every few weeks. This minimized risk and allowed for rapid feedback. Results: increased deployment frequency. They went from annual releases to deploying critical applications several times a month. Reduced lead time. The time from a code commit to production went from 3 months to 2 weeks for key systems. Significant improvement in MTTR, mean time to recovery. Incidents, when they did occur, were resolved much faster due to automated alerting and better collaboration. Higher employee satisfaction. Teams reported less friction, more constructive collaboration, and a greater sense of shared ownership. Accelerated digital transformation. They could launch new digital products and features much faster, creating a significant competitive advantage in the insurance market. CloudGen's journey illustrates that DevOps is a marathon, not a sprint, deeply rooted in cultural change and continuous improvement. By integrating development and operations, organizations can unlock unprecedented speed, reliability, and innovation in their software delivery capabilities. Chapter 9, Beyond the Basics, Exploring Other Methodologies and Frameworks. While Waterfall, Scrum, Kanban, Lean, and DevOps form the backbone of modern software development discussion, the landscape is rich with other valuable methodologies and frameworks. Some offer alternative prescriptive approaches, others focus on specific engineering practices, and some address the challenge of scaling Agile across large organizations. Understanding these variations broadens our perspective and provides a more comprehensive toolkit for tackling diverse project needs. 9.1 Extreme Programming (XP), Engineering Excellence and Discipline. Born in the late 1990s, Extreme Programming (XP) is one of the earliest and most influential Agile methodologies. Conceived by Kent Beck, XP takes good software engineering practices and extends them to extreme levels. It's highly prescriptive, emphasizing a set of core values and practices designed to produce higher quality software more predictably while reducing the cost of change. XP is particularly strong for small to medium-sized teams developing new software with constantly changing requirements. Key values of XP: communication, face-to-face communication over written documentation. Simplicity, do what's needed for today, not for tomorrow. Feedback, frequent and fast feedback from customers, team members, and automated tests. Courage, being brave enough to make changes, refactor, and adapt. Respect, for colleagues and customers. Core practices of XP and how they are extreme: pair programming, 2 developers work together at one workstation. One writes code and the other constantly reviews and suggests improvements. This enhances code quality, knowledge sharing, and reduces defects. Extreme communication and continuous review. Test-driven development (TDD), writing automated tests before writing the actual code that makes the test pass. This ensures comprehensive testing, clear understanding of requirements, and high code quality. Extreme feedback and quality focus. Continuous integration (CI). Developers integrate their code into a shared mainline multiple times a day. Each integration is verified by an automated build and battery of tests. This catches integration issues early. Extreme integration and early detection. Refactoring. Continuously improving the internal structure of code without changing its external behavior. This keeps the code clean, maintainable, and adaptable to future changes. Extreme design and ongoing quality. Small releases. Delivering working software to customers as frequently as possible, typically every 1 to 2 weeks. Extreme feedback and fast delivery. Simple design. The design should be simple enough to be understood by everyone on the team and meet the current needs, without anticipating future requirements. Extreme simplicity. Planning game. A collaborative planning approach between customers and developers to prioritize features and estimate work. On-site customer. A customer representative is physically present with the development team, answering questions and providing immediate feedback. Extreme customer collaboration. Collective ownership. Anyone can change any part of the code to improve it. Coding standards. Agreed upon guidelines for code style and structure to ensure consistency and readability. XP is often challenging to implement in its entirety because it requires significant discipline and trust. However, its emphasis on engineering excellence has deeply influenced modern software development, with practices like TDD, CI, and refactoring becoming standard across many Agile frameworks. 9.2 Crystal Family of Methodologies, Adapting to Context and People. Alistair Cockburn, one of the original signatories of the Agile Manifesto, developed the Crystal family of methodologies. Unlike a single, fixed approach, Crystal is a methodology for methodologies, acknowledging that no single process fits all projects. Instead, it offers a family of methodologies tailored to the specific characteristics of a project, primarily focusing on people, their interactions, and communication. Cockburn argues that a methodology can be characterized by 2 primary dimensions: team size, how many people are on the project; criticality, how severe would the potential damage be if the system failed; e.g., loss of comfort, discretionary money, essential money, or life. Based on these dimensions, Crystal suggests different colors of methodologies, e.g., crystal clear, crystal yellow, crystal orange, crystal red, each recommending a different level of process formality and communication needs. Core tenets of Crystal: frequent delivery, deliver working software frequently, every few weeks, months. Reflective improvement, team members regularly reflect and tune their process. Osmotic communication, team members should ideally be in the same room to facilitate knowledge sharing. Personal safety, team members feel safe to speak up, challenge ideas, and admit mistakes without fear of retribution. Focus, team members know what to work on and have minimal distractions. Easy access to expert users, developers have direct access to users for questions and feedback. Technical environment with automated tests, configuration management, and frequent integration provides a stable foundation for development. Crystal Clear, designed for small, up to 6 people, non-critical projects, is the lightest in the family. It emphasizes high communication, frequent delivery, and continuous improvement with minimal overhead. As projects grow in size or criticality, the recommended Crystal method, e.g., Crystal Orange for 10 to 40 people with essential money damage, adds more formality, documentation, and coordination mechanisms, but still preserves the core human-centric principles. Crystal's strength lies in its explicit recognition that methodology choices are contextual and fluid, prioritizing communication and adapting development practices to the specific characteristics of the project and the people involved. 9.3 Dynamic Systems Development Method, DSDM, a comprehensive Agile framework. The Dynamic Systems Development Method, DSDM, is one of the oldest Agile frameworks, predating the Agile Manifesto. Developed in the UK in the mid-1990s, DSDM provides a comprehensive framework for project management and product delivery that aligns with the principles of iterative and incremental development. It's often used in environments that require more rigor and governance than some of the lighter Agile approaches, but still demand speed and flexibility. Core principles of DSDM: focus on the business need, deliver real business benefits, deliver on time. Timeboxing is central to DSDM. If scope must be reduced, it is. Collaborate, active and empowered user involvement. Never compromise quality. Quality is baked in, not an afterthought. Build incrementally from firm foundations. Start with a good overall structure, then build in small steps. Develop iteratively. Cycles of learn and refine. Communicate continuously and clearly. Effective communication is key. Demonstrate control, maintain visibility, and manage risks. DSDM project lifecycle. DSDM typically follows a phased approach, similar to RUP, but with an agile iterative focus. Feasibility study. Assess if the project is viable. Foundations. Define the overall business and technical architecture and project plan, high level. Evolutionary development. This is the iterative and incremental core, where the development team rapidly produces iterations of the working software. This phase involves cycles of functional model iteration, analysis and design and build iteration, coding and testing, implementation iteration, deployment and user training. Deployment, release the completed system. DSDM places a strong emphasis on continuous user involvement, clear roles and responsibilities, frequent delivery, and integrated testing. It also uses a MOSCOW prioritization technique, must have, should have, could have, won't have, to manage scope and ensure delivery within fixed deadlines. DSDM's structured approach makes it appealing to organizations that need to embrace Agile but still demand a predictable project management framework. 9.4 Hybrid approaches. Blending methodologies for unique contexts. In the real world, it's rare to find a project that adheres strictly to a single methodology. More often, organizations adopt hybrid approaches, blending elements from different methodologies to create a custom solution that best fits their unique context. This pragmatic approach acknowledges that every project, team, and organization has specific needs and constraints. Common hybrid examples include Scrumban. This combines the time-boxed sprints and roles of Scrum with the flow optimization and WIP limits of Kanban. Teams might use sprints for planning and retrospectives, but manage their daily work visualizing flow on a Kanban board, pulling tasks when capacity allows. This is particularly useful for teams with unpredictable incoming work or a mix of project and maintenance tasks. Agile Waterfall Hybrid, sometimes called Wagile, this is often seen in larger organizations trying to transition from traditional waterfall to Agile. The upfront phases, e.g., high-level requirements, architecture, might be more waterfall-like, while the execution, development, testing occurs in Agile sprints. While often criticized for potentially diluting Agile benefits, it can be a pragmatic bridging strategy in complex environments or highly regulated industries. Lean Agile. This is less a hybrid methodology and more an integration of philosophies. Many organizations adopt Agile frameworks, like Scrum or Kanban, while deeply embedding lean principles of waste elimination, continuous improvement, and value stream optimization. This ensures that the Agile practices are maximizing efficiency and customer value. The key to successful hybrid approaches is to consciously and deliberately select the best elements from various methodologies, ensuring they complement each other and address specific project needs, rather than haphazardly combining practices. 9.5 Scaling Agile. Brief overview of leading frameworks. While Scrum and Kanban are excellent for individual teams, large enterprises with hundreds or thousands of developers working on complex products face the challenge of coordinating multiple Agile teams. This is where scaled Agile frameworks come into play. They provide guidance on how to apply Lean Agile principles across multiple teams, departments, and even across entire organizations. 3 prominent frameworks for scaling Agile include Scaled Agile Framework, SAFe. This is perhaps the most comprehensive and widely adopted scaled Agile framework. SAFe provides a layered approach: team, program, large solution, portfolio, with roles, ceremonies, and artifacts to coordinate multiple Agile teams, align them with business strategy, and deliver large, complex solutions. It offers detailed guidance on how to manage enterprise backlogs, value streams, and program increments. SAFe is known for its prescriptive nature and is often favored by large, traditional enterprises seeking a structured path to Agile transformation. Large-scale Scrum, LSS. LSS takes the Scrum framework and applies it to multiple teams working together on a single product. It promotes the idea of Scrum at scale by minimizing additional roles or processes beyond standard Scrum. It emphasizes 2 key configurations: LSS for 2 to 8 teams and LSS Huge for more than 8 teams. LSS aims to preserve the simplicity, transparency, and empiricism of Scrum while designing the organization around the teams working on the product. Disciplined Agile DA. This framework, now part of PMI, the Project Management Institute, is less a prescriptive framework and more a toolkit or process decision framework. DA provides guidance on how to choose and tailor strategies for different contexts. It emphasizes that Agile is a series of choices, not a one-size-fits-all solution, providing a rich collection of strategies, goals, practices, and roles that teams can pick and choose from based on their specific needs and situation. It integrates principles from Lean, Scrum, XP, and others. These scaled Agile frameworks recognize that simply replicating single-team Agile practices across an enterprise is insufficient. They provide mechanisms for alignment, communication, and coordination at a larger organizational level, enabling large businesses to achieve the benefits of agility. Exploring these other methodologies and frameworks demonstrates the rich tapestry of approaches available in software development. No single methodology is a magic bullet, but by understanding their unique strengths and the situations they address, teams and organizations can piece together the most effective strategies for their specific challenges. This deep understanding is crucial for making informed decisions, which will be the focus of our next chapter. Chapter 10, Choosing Your Path, Selecting the Right Methodology for Your Project. 10.1 No One Size Fits All. The importance of context and adaptability. By now, it should be abundantly clear that there is no universal best software development methodology. Each framework, from the structured Waterfall to the adaptive Scrum, the flow-focused Kanban, the waste-eliminating Lean, and the collaborative DevOps, offers unique strengths and caters to different needs. The right methodology is entirely dependent on the context of your project, your team, and your organization. Trying to force a square peg into a round hole by rigidly applying one methodology universally will likely lead to frustration, inefficiencies, and ultimately, project failure. For instance, attempting to use the rigid waterfall model for a highly innovative, rapidly evolving startup product would be as ill-advised as trying to manage a critical, highly regulated medical device project with a purely experimental, undocumented Agile approach. The key to success lies not in finding an arbitrary best, but in developing the discernment to select, adapt, and even combine methodologies in a way that optimizes for the specific conditions and desired outcomes of your particular endeavor. This chapter will equip you with a framework for making those critical decisions. 10.2 Key factors to consider when choosing. When evaluating which methodology or combination of practices might be most suitable, consider the following critical factors: project type and complexity, well-defined versus exploratory. Is the end product clearly understood from the outset, or is it an innovative, exploratory project where requirements will emerge over time? Waterfall is better for the former, Agile for the latter. Scale. Is it a small, single-team project or a massive, multi-team enterprise undertaking? Smaller projects might thrive with pure Scrum or Kanban, while large ones might require SAFe or LSS. Criticality. What are the consequences of failure? High criticality projects, e.g., medical, aerospace, often demand more rigorous planning, documentation, and verification, which might lean towards V-model or more disciplined Agile like DSDM. Requirement stability and volatility. Stable. If requirements are fixed, likely to remain unchanged, and fully specifiable upfront, Waterfall might be considered. Volatile. If requirements are expected to change frequently, are unclear, or need to emerge through experimentation and feedback, Agile methodologies, Scrum, Kanban, are far more appropriate. This is perhaps the most significant discriminator between traditional and Agile approaches. Team characteristics, size and structure. Small, co-located teams often do well with simpler Agile. Larger, distributed teams might need more structured communication or scaled Agile frameworks. Experience level. Experienced, self-organizing teams can handle the fluidity of Agile. Less experienced teams might initially benefit from a more structured, but still iterative, framework. Culture and mindset. Is the team comfortable with collaboration, self-organization, and rapid change? Or are they accustomed to hierarchical structures and strict instructions? A cultural shift often needs to precede or accompany a methodological change. Availability. Is the team and product owner available for frequent, direct communication and collaboration? Agile thrives on this. Organizational culture and maturity. Hierarchy versus empowerment. Does the organization support empowered, self-organizing teams, or does it prefer command and control? Agile requires a shift towards empowerment. Risk tolerance. Is the organization comfortable with iterative delivery, learning from mistakes, and adapting? Or does it demand upfront certainty, even if it's false? Customer engagement. Is the organization willing and able to engage customers frequently and collaboratively throughout the development process? Existing infrastructure. What legacy systems or development practices are in place that might hinder or support a new methodology? Regulatory environment compliance needs. Some industries, e.g., finance, healthcare, defense, have strict regulatory requirements for documentation, traceability, and sign-offs. While Agile can and does work in these environments, it may require specific adaptations and careful attention to auditing practices, sometimes leaning towards a more structured Agile approach like DSDM or a hybrid. Customer involvement level, high engagement. If the customer is willing and able to be deeply involved, provide continuous feedback, and collaborate closely, Agile methodologies are ideal. Low engagement. If the customer is only available early on, e.g., due to contracting models, traditional waterfall-like approaches might seem to be the only option, though often a flawed one. Risk profile. Which risks are most prominent? Technical risk and uncertainty push towards iterative, market risk and volatility push towards frequent delivery. A blend may be necessary. 10.3 Assessing your project and organization. A practical framework. To systemically apply the factors mentioned above, consider a simple framework for assessment. Define project goals and vision. What problem are you solving? For whom? What does success look like? This helps ground all subsequent decisions. Assess requirement stability. On a scale of 1 to 5, 1 equals 100% known and stable, 5 highly uncertain and expected to change, where do your requirements fall? A score of 4 to 5 strongly suggests Agile. Evaluate project complexity and size. Complexity: how many integrations? How many unknown technical challenges? How many stakeholders? High complexity indicates a need for iterative feedback. Size: how many teams? How many team members? More people require more sophisticated coordination. Analyze team readiness. Skills: do team members have the technical and soft skills needed for a given methodology, e.g., cross-functionality for Scrum, discipline for TDD and XP? Mindset: is the team open to continuous learning, self-organization, and potentially radical changes in how they work? Understand organizational culture. Leadership support: is management willing to provide the necessary support, training, and protect the team from external pressures? Customer access: can you get frequent, direct access to actual users or product owners? Process bureaucracy: how much existing overhead, documentation, sign-offs is there, and how willing is the organization to streamline it? Consider the following analogy for quick guidance. Building a known, well-defined bridge, waterfall or V-model. Requirements stable, low change, high criticality equals need for upfront planning. Exploring a new, innovative product, e.g., a groundbreaking app, Scrum. Requirements volatile, high learning, need for frequent feedback. Managing an ongoing flow of varied work, e.g., support, maintenance, small enhancements. Kanban. Focus on workflow, flow, and efficiency. Optimizing value delivery across product lines by constantly eliminating waste. Lean, overarching philosophy, not a specific methodology. Breaking down silos between development and operations for rapid, reliable deployment. DevOps, cultural and technical integration. Developing a single, high-quality feature with a small, senior team. XP, engineering discipline focus. Coordinating many teams on a large, complex product in a structured enterprise. Safe/LSS/DA. Scaling Agile. 10.4 The art of tailoring and combining methodologies. Customizing your approach. In reality, most successful implementations involve tailoring a methodology to fit the specific context, or combining elements from different methodologies, hybrid approaches. This isn't doing Agile wrong. It's doing it intelligently and pragmatically. Tailoring. If you pick Scrum, you might decide to have sprints of 3 weeks instead of 2, or you may adapt the daily Scrum time based on team size. The key is to understand the purpose behind each practice and adapt in a way that preserves that purpose, rather than undermining it. For example, shortening the sprint retrospective due to time constraints, but ensuring it still happens and results in actionable improvements. Combining hybrid. As discussed in Chapter 9, Scrumban is a popular combination. Large organizations might use a hybrid model where higher-level portfolio planning might look more traditional, but individual development teams operate in an agile fashion, e.g., a scaled agile approach. A product team might use Scrum for core development, and the operations team might use Kanban for handling incident management. The process of tailoring and combining is a continuous one. As your project evolves, as the team learns, and as the market changes, your chosen approach should also adapt. 10.5 Starting small and iterating. Pilot projects and gradual adoption. For organizations new to Agile or contemplating a shift, attempting a big bang rollout across all projects is highly risky. A more successful strategy involves pilot project. Select a small, contained, ideally non-critical project with a willing team and engaged stakeholders. Use this as a learning laboratory. Team autonomy. Allow the pilot team the autonomy to experiment, make mistakes, and learn from them. Protect them from external pressures during this learning phase. Continuous improvement. After the pilot, conduct a thorough retrospective. What worked? What didn't? How can the process be improved before wider rollout? Gradual expansion. Once successful, gradually expand the new methodology to more teams, leveraging the lessons and experienced members from the pilot. This iterative approach to methodology adoption itself embodies Agile principles. Start small, get feedback, adapt, and scale what works. 10.6 The critical role of leadership in methodology adoption. No matter which methodology is chosen, its successful adoption critically hinges on leadership support and sponsorship. Without strong backing from management, cultural resistance, teams will struggle to change old habits. Resource constraints, necessary training, coaching, and tools might not be provided. Lack of empowerment. Teams might not be given the autonomy to truly self-organize. Conflicting priorities. Leadership might impose traditional metrics or demands that undermine the benefits of the new methodology. Leaders must understand and champion the new approach, not just in words but through their actions. Provide a supportive environment, remove impediments, trust teams, and embrace learning from failure. Align organizational goals. Ensure that performance metrics and incentives support the behaviors the new methodology encourages. Be patient. Transforming how an organization builds software takes time, effort, and continuous adaptation. Choosing the right software development methodology is a strategic imperative. It requires a deep understanding of your context, an honest assessment of your capabilities, and a willingness to adapt. By carefully considering all the factors, assessing your environment, and embracing a continuous learning mindset, you can select and evolve the blueprint that best guides your next software adventure to success. Chapter 11. The journey continues. Adapting and evolving in software development. 11.1. Common challenges in adopting and sustaining methodologies. Implementing a new software development methodology, or even adhering to an established one, is rarely a smooth, linear process. Despite the clear benefits and well-documented practices, organizations frequently encounter significant hurdles. Understanding these common challenges is the first step toward overcoming them. Cargo cult, Agile, or Scrum Kanban. One of the most prevalent pitfalls is adopting the superficial practices of a methodology without understanding or embracing its underlying principles and mindset. Teams might perform daily stand-ups, use a Kanban board, or conduct sprints, but if they lack genuine collaboration, continuous feedback, or a focus on working software, they're merely mimicking the rituals. This leads to little actual improvement and fosters cynicism within the organization. Resistance to change. Humans are creatures of habit. Project managers accustomed to detailed Gantt charts might resist giving up control. Developers might be uncomfortable with pair programming or test-driven development. Operations teams might resist the idea of owning deployment responsibility. These deeply ingrained habits and fears can severely impede adoption. Lack of strong leadership support. While the development team uses the methodology, its success often depends on leadership creating an enabling environment. If management pays lip service to Agile but continues to demand fixed scope, fixed price contracts, or imposes top-down decisions without team input, the methodology will likely fail. Inadequate training and coaching. Simply providing a book or a one-day course is insufficient. Teams need ongoing training, mentorship, and experienced coaches to truly internalize new ways of working and overcome initial difficulties. Siloed organizational structures. Many traditional organizations are structured departmentally, e.g., separate QA, Dev, Ops. Methodologies like Scrum and DevOps champion cross-functional teams and blurred boundaries. Forcing these new ways of working into old organizational structures creates friction and inefficiency. Focus on process over people value. Some organizations become overly bureaucratic, prioritizing strict adherence to process rules rather than focusing on delivering value or fostering a healthy team environment. This often leads to unnecessary overhead and diminished morale. Technical debt and legacy systems. Older systems with tangled codebases and infrequent releases can make it incredibly difficult to adopt practices like continuous integration, frequent releases, or automated testing, creating a significant barrier to agility. Successfully navigating these challenges requires more than just technical prowess. It demands a deep understanding of organizational dynamics, behavioral economics, and the human element in software development. 11.2 Overcoming Obstacles. Best Practices for Success. Addressing the challenges outlined above requires a concerted, multi-pronged approach that goes beyond simply doing a methodology. Invest in continuous education and coaching. Provide ongoing training for all team members, not just developers. This includes foundational workshops, advanced topic seminars, and having experienced Agile coaches on hand to guide teams, facilitate ceremonies, and resolve conflicts. Learning isn't a one-time event, it's continuous. Secure executive buy-in and sponsorship. Leaders must actively champion the chosen approach, communicate its importance, and visibly participate. They need to protect teams during the transformational period, provide the necessary resources, and align incentives. This often means being willing to change their own behaviors and expectations. Start with a pilot and iterate. Don't try to transform the entire organization overnight. Choose a willing team, a manageable project, and let them be a learning laboratory. Gather feedback, address issues, demonstrate success, and then gradually expand the adoption based on empirical learning. Empower teams and foster self-organization. Trust your teams. Provide them with a clear vision and outcome, then allow them to determine how best to achieve it. Remove blockers, offer support, but avoid micromanagement. Recruit and retain talent that thrives in such environments. Emphasize psychological safety. Create an environment where team members feel safe to experiment, fail, admit mistakes, ask for help, and challenge the status quo without fear of punishment. Blameless postmortems for incidents are crucial for learning. Focus on value and outcomes, not just output. Shift metrics from activities, e.g., lines of code, number of meetings, to actual business value delivered, e.g., customer satisfaction, reduced lead time, increased revenue. Foster cross-functional collaboration. Actively break down silos. Encourage developers, testers, operations, and business analysts to work together daily, share knowledge, and take collective ownership of the product. Address technical debt proactively. Make technical quality and maintainability a regular part of the work. Refactor constantly. Automated testing and continuous integration are non-negotiable for long-term agility. Cultivate a culture of continuous improvement. This is at the heart of all modern methodologies. Regularly review processes, identify areas for improvement, experiment with changes, and measure their impact. This iterative approach to process improvement is itself Agile. 11.3 The human element. People, culture, and mindset are paramount. Throughout this book, while we've explored various models, principles, and tools, a recurring theme has emerged. Software development is a human endeavor. Technologies change, frameworks evolve, but the core challenges of communication, collaboration, understanding, and creativity remain. No methodology, however scientifically sound, can substitute for the human elements of talent and skill. Highly skilled and motivated individuals are indispensable. Communication. Clear, empathetic, and frequent communication, especially face-to-face. Trust. Between team members, between teams and management, and between the organization and its customers. Empathy. Understanding the user's needs, the challenges of teammates, and the goals of stakeholders. Leadership. Not just management, but leadership that inspires, guides, and removes obstacles. Psychological safety. The ability to be vulnerable, to innovate without fear of failure, and to challenge assumptions. Culture. The collective values, beliefs, and practices within an organization exerts an immense influence on how any methodology is adopted and executed. An organization with a command and control culture will struggle to adopt Agile, no matter how many Scrum masters they hire. Similarly, a blame-oriented culture will sabotage DevOps efforts. Ultimately, successful software development methodologies are about enabling people to work more effectively together to solve complex problems. They provide a framework for human interaction, learning, and value creation. The most successful organizations are those that invest in their people and cultivate a culture that aligns with the principles of agility, continuous learning, and adaptability. 11.4 The future of software development methodologies. Emerging trends and AI's impact. The evolution of software development methodologies is far from over. As technology continues its relentless march, so too will the ways we build software. Several trends are shaping the future. Further automation. The drive for automation, particularly in testing, deployment, and infrastructure management, DevOps, will continue to intensify. Zero-touch deployments, self-healing systems, and sophisticated monitoring will become standard. Greater focus on security, DevSecOps. Integrating security practices seamlessly throughout the entire software lifecycle and making security a shared responsibility will become even more critical than it is today. Low-code, no-code platforms. These platforms allow individuals with limited coding knowledge to build applications, democratizing software creation for certain types of applications. This shifts the focus of traditional development teams to building the more complex, custom components and integrations that underpin these platforms. AI and machine learning's role. AI-assisted development. AI tools are increasingly assisting developers with code completion, bug detection, automated testing, and even generating code snippets. This can accelerate development and improve quality. AI in operations. AI Ops, artificial intelligence for IT operations, uses AI to analyze massive amounts of operational data, predict issues, and automate responses, further enhancing system stability and performance. Methodology selection guidance. While not yet mature, AI could potentially assist in recommending optimal methodologies or tailoring practices based on project characteristics and organizational data. Hyper-personalization and customization. Rather than one-size-fits-all frameworks, we may see even more emphasis on highly customized approaches, dynamically adapting to microcontexts within an organization. Disciplined Agile, which offers a toolkit of practices, hints at this future. Sustainable and ethical software development. As software becomes more pervasive, there will be growing emphasis on building software sustainably, e.g., energy consumption, resource usage, and ethically, e.g., bias in AI, data privacy, responsible use of technology. Methodologies will need to incorporate these considerations. Organizational agility beyond IT. The principles of Agile, Lean, and DevOps are extending far beyond the IT department, influencing how entire organizations, marketing, HR, finance, leadership, structure their work, manage change, and deliver value. The future points toward systems that are not only faster and more reliable, but also more intelligent, automated, and seamlessly integrated into the fabric of the business itself. 11.5 Final thoughts. Embracing continuous learning and adaptation. The journey through software development methodologies reveals a constant quest for better ways of building. From the early attempts to impose order with Waterfall, through the iterative and incremental steps, to the revolutionary shift of Agile, Lean, and DevOps, the industry has continuously learned and adapted. The most important takeaway is not to memorize a specific methodology, but to grasp the underlying principles, embrace change, prioritize working software and customer value, foster strong communication and collaboration, continuously learn and improve, eliminate waste, automate what you can. Software development is a dynamic field. The tools and techniques will continue to evolve, but the fundamental challenges of translating ideas into working solutions while navigating complexity, managing change, and collaborating effectively will endure. By internalizing the lessons from the various methodologies and adopting a mindset of continuous learning and adaptation, you and your teams will be well equipped to navigate the exciting, ever-changing landscape of software creation. The journey truly continues.